Mostly in Python and Django, also some Node.js, C Sharp, and some others. For this particular project, we're going to be building an analytics dashboard using Python and Django. I think it's going to be a really fun project. I think if you want to learn more about Python and Django, the best way is to go ahead and build real applications. So as far as what we're going to do in this project, we are going to kind of follow a little bit of a process here. So we're going to go through a number of sessions. We're going to start with kind of some foundational things like setting up the Django project, establishing database connections, setting up some views, view controllers, URLs, that kind of thing. And then we'll take a look at some various ways of importing data into our project. In the next session, we'll kind of do a basic review of data structures in Python, some of the things that are available to us, how we can use them to our advantage. We'll have a discussion about the ORM model and native SQL queries. It's kind of a speed versus ease of use type of discussion, but there's some points to be touched on there for sure. Then we'll move on to building the actual ORM models. From there, we'll kind of establish, what the end result is of what we want to see data-wise, and then we'll go ahead, build the business logic, math functions, and everything needed to do that, and then we'll work on passing that data into the view controller. And then to round out the first tutorial here, we'll look at how we handle that data with the native Django templating language, as well as look to visualize that data using some third-party JavaScript libraries like D3, NVD3, charts.js, maybe some others. We'll see how much time we have. And that should cover kind of the fundamentals of the project. If we get a good response, we'll look at doing some more advanced tutorials from there. But I think this should give anybody a good handle on getting a new data analytic, data visualization type project up and going. All right, so I guess we're going to do a little tutorial, if you will. I don't know if I call it a tutorial. Let's not do it like that. Let's make it a little more interactive. We'll do some collaborative stuff here. Python, some Django. We'll kind of walk through, what it takes from start to finish to build a application, allow you to analyze, visualize, and I guess more than that, just get meaningful insights into, whatever data set, presents itself for you. I think the plan is we'll kind of go start to finish. We'll go from creating a brand new Python Django project. We'll lay out the framework. We'll take a look at some data, import it, and then we'll kind of get to the fun stuff. Definitely want to make this as interactive as possible. If you guys have any questions, anything you want to see more in depth, anything you want to pass over, feel free and let me know. Python frameworks. Yeah, so I think we're going to use Django for this one. I think for what we're trying to do, it's kind of the most complete out of the box. I'm also a big fan of some of the other Python frameworks out there, Flask in particular. But with Flask, to do some of the things that we're going to do, you need to bring in a few other libraries, a few other modules, and it just makes it a little more complicated. So I think for this one, we'll start with Django and go from there. As far as assumptions go, I'm going to assume you guys at least have some familiarity with Python. Past that, I think we'll kind of cover everything else step by step. So if you're new to Django, I wouldn't worry about it. I wouldn't worry about it too much. So I guess barring that, any questions, or let's get it going. Obviously, first thing we need to do is create a new project. So I guess actually I'll touch on real quick before we get there. Editors, IDEs, things like that. I'll circle back to that in just a second. Big thing with editors, IDEs. I personally like PyCharm. It's made by JetBrains. They make IDEs for about every language that's out there. It's what I've used forever. It's what I like. It's what I tend to use. You can go to their website, download PyCharm Pro. I'm sure there's a 30-day free trial or something like that. But don't get too caught up in that. Anything you see done in PyCharm, you can just as easily do in Sublime, Atom, whatever the editor of your choice is. So I'll try and, at least in the beginning here, kind of show you both ways of going about it, as far as if you were creating a new Django project without the ease of doing it through the IDE. As far as the big difference between Flask and Django, Flask is a lot more lightweight. You can definitely get apps up and going significantly quicker, and it's a lot less overhead resource-wise. Django's a lot more full-featured, a lot more bells and whistles. Just about anything conceivable in a web framework you'd want, Django probably has it built in. Where Flask, there's a lot of, like I said, depending upon what you're trying to do, there's a lot of third-party libraries and stuff like that you need to pull in. So let's go ahead and get a new project going for this. Call this live edu1. Call our application dashboard. So obviously starting a new project within the IDE, pretty straightforward, not a whole lot to it. If you are running Linux, a Mac, anything like that, you can also kind of get a new project started through a terminal window. So if I wanted to start a new project through the terminal window, you just do Django admin start project and then whatever the project name is going to be. So we'll just call it live edu2. So that should have started a new Django project for me. Yeah, there it is. So if you enter into the project, you'll see kind of the base directory as well as the manage.py file. If you see the manage.py file, you know you did it right. Manage.py is kind of the the engine that powers all the commands for Django. So to kind of get to where we'd be if we were trying to catch up with the editor, we have the base directory, we have the manage.py file. At this point, we'd also want to start a app, which we call dashboard in the other one, so we'll do it here too. And then we'll use that manage.py function to get there. So that should have gave us a new app called Dashboard with everything we need inside of that. And then at this point, you'd probably also want a template directory, which we'll get a little more into later. So that's kind of the starting folder of what you want to look like on a new project. Pandas. Yeah, Pandas is great. If we have some time in some of the later sessions, we'll definitely touch on Pandas. It is a great library, especially for data analytics and analyzing data, things like that. Alright, so back to the editor. Housekeeping things here. We'll cover URLs in a bit. Settings.py, so this is where all of your application settings are going to be stored for the most part. For this particular project, I think what we're going to do is take a data set. In this case, it's going to come from a CSV, and we're going to dump it into an actual SQL database, and then use Django ORM to manipulate the data from there. If that doesn't mean a whole lot to you yet, don't worry, we'll certainly get there. The first thing that we want to do is adjust the database's setting in the settings file. Django supports a bunch of different databases that it'll natively integrate with and natively work with. I think for this project we're going to go with MySQL just because it's one of the more universal platforms out there. It's open source, it's free, it's super popular. So we'll start there. Postgres is a great one. Most SQL databases you can use here. So what we need to do is change a couple of settings here. So we're going to change the engine from the default SQLite to MySQL. So here it's asking us for the name of the actual database within MySQL that we're going to be using. So we'll call it live.edu. We'll go ahead and actually create that database here in just a minute. Oh, I see what's going on. Some other parameters we're going to have to pass into the settings file is the username. For this tutorial, we'll keep it simple. We'll use root. Obviously, if this was a production environment, something like that, you're going to want much better username and passwords here. We're also going to specify the password. I guess we'll just use root again. And then the last thing it's going to need is going to be the host. In this case, it's just going to be localhost because we're going to run it on the same machine. Alright, and that should get us a database connection. What ID are you using? I'm using PyCharm from JetBrains. Definitely go check them out. Should be a free trial on their website. But again, anything you see done here in PyCharm, you can do in Atom, Sublime, whatever your editor of choice is. So now that we have the database connections in, next thing we should probably do is create the database within MySQL. While we're doing this, should probably also kind of touch on why Python and Django, but more Python specifically for data analytics, data visualization. And I think the biggest bit for a lot of people out there is it allows you to build really meaningful applications that give you great insights into data and do analytics that you don't have to be a SQL expert to do. You don't have to be a certified DBA. You don't have to be able to rock out all kinds of really complex SQL queries. Once you kind of establish and lay the groundwork with just a little bit of SQL knowledge, you can use your Python skills to really do transformational things with data, and I think that's one of the things that I love about it the most. So now that we're into the MySQL prompt, we're just going to create the database that we specified in our settings file. Alright, so we're just checking the database was in fact created. Currently there are no tables in the database. So what we'll do is go ahead and use Django to kind of set up the basic foundation within SQL that we're going to need for the Django program to work. So it's just Python manage.py migrate, and that's going to make all the initial database tables that we need for the application to function. So now if we go back and we look at our database, we have kind of the basic foundation that we're going to use for the rest of the project. Alright, so that covers database setup. Where do we want to go next? Well, I guess next let's take a look at the data we're going to use for this. So I was messing around online today trying to find a decent data set that we could use for the for this project. I will look through a lot of data, and there's some interesting stuff out there. I wasn't really sure what we should use here. I come from a call center world, so I mess with call center data pretty much all day, every day. So I kind of wanted to do something a little different than that. What I found was some data from a financial institution about all the loans that they've made through the first quarter of 2017. It's a pretty decent subset of data. It's about 100,000 lines. And it just has some interesting stuff on it. Some stuff we can use to see if there's correlations between anything from interest rates and loan amounts to employment length or home ownership status. We'll kind of have a little conversation as we go on some interesting things we might be able to pull out of the data. But I think this will give us a good foundation of stuff to work with. So that is what we're going to use. I will be posting all the code here to GitHub. And I'll have a link in the description of the project before the night's out here, where you can download the actual code if you want it, and I'll also throw up the data set somewhere so you can pull it down if you want to follow along at home. So I guess next step, as far as building this framework and moving this project along, is we need to do two things. So we need to set up our SQL database in a way that it's going to accept this data. So if you think about SQL databases, And then you think about Excel spreadsheets or CSV files, whatever you want to go with. They're really, really very similar in concept. So when you look at a database, it's very much rows and columns, structured data, much the same as a spreadsheet. The difference is going to be size and capacity. This is a 100,000 line spreadsheet, and it's pretty unwieldy to deal with, to manipulate, to look through. Whereas you can get millions upon millions of lines in a database, and it's not such a big deal. So in order to get the data from the spreadsheet into our SQL database so it's accessible in our app, we need to start one of two places, which is either going to be, let's start with models. So I was planning on covering this in a future episode, but it's going to prove to be rather important for today, so we're going to do it now. One of the neat things about Django, again, and this is kind of moving back a little bit, is the ability to build applications, build SQL databases, analyze SQL databases without the need to really know that much SQL. I highly recommend learning SQL. It's always going to be valuable, and we'll even have a talk about why it may be better than some of the ways we're going to do things in this particular project. But at any rate, Django gives us a way to manipulate the database much in the same way if we were to go into SQL and actually create a database, create the columns, and things like that. And the way it lets us do that is through models, object relational mapping. Essentially what we're going to do is we're going to create a model of our database, and then we're going to let Django actually make the physical changes to the database, so we have a structure that'll allow us to import the data from the spreadsheet that we just looked at. So first thing we're going to need to do is kind of have this up. I'm going to throw this on another screen, so I apologize for that. And so essentially what we're going to do is we're just going to define all of our columns. So we're going to start at loan amount, and then we're going to go through all of the columns that are going to be in our database, and then we're more or less going to define them in a way that Django understands, that can translate into setting up our SQL database for us. So this bit's a bit tedious. Feel free to sit back, grab some popcorn. Hopefully we'll get through it rather quickly. Go faster if I could type. So what this is we're basically specifying the table header, and then we're using the models library, which is kind of again how Django translates it to I should probably declare the class first. Is kind of how Django is going to translate it into SQL. So we'll call this database loans. So within Django has a bunch of built-in types of models. What we want to do is kind of correlate the type of model to the particular data point that we're going to see in the spreadsheet. So for example, loan amount, if we just scan it, it looks like it's all going to be integers. Same with funded amount. Once we get into term, interest rate, we're going to be using a character field, which it equates into like a varchar field in SQL. And then we'll kind of do that all the way through, if that makes sense. If anybody has any questions, feel free to jump in here. When you use a character field, you do need to specify the max length of the field. Generally for prototypes, for what we're doing, it's not super important, as long as you make sure you have enough room for whatever you're trying to capture within the field. We're also going to make this one a char field. If you look at the way it's set up in the interest rate with the percentage sign, if we try to make it a float number, the percentage sign is actually going to cause us a problem. We could go ahead and strip it out when we import the data, but we can do that later, so it's not a huge deal. We'll call this one a float field. No, looks like an integer field. We'll call it an int field. How much time it takes to get finish? Finish what? It'll take probably another 5 minutes or so to create this this class here. But as far as finish the whole project, we're probably talking, I don't know, 3-4 episodes, something like that. Depending upon how deep you guys want to get into it, we can certainly add on at the end with some more, advanced stuff if we don't cover everything you're looking to see. And again, all I'm doing is taking all of the headers for the columns off of our CSV that we're going to pull into our SQL database, and then just defining them to Django and letting Django know what type of value to expect, whether it's an integer, a float field, a character field, date, whatever. So zip code, this is something you'd probably normally define as an integer, but because they, looks like probably sanitize the data a bit, the Xers are going to cause it to be a character field for the time being. Promise the whole thing isn't as boring. Just some of the laying the initial groundwork is a bit tedious. But once we kind of get that done, we can move on to some more fun stuff like playing with the numbers and making pretty things. Alright, so this is what the data model looks like. Again, if we compare it to our spreadsheet, all we're really doing is defining each of the columns. Again, this is going to set up our database for us. So we kind of just followed the pattern here. So we loan amount, funded amount, term, interest rate, etc., all the way down, and we just try and match the data type that looks like it's going to be most commonly found inside the cells to the type that it's going to relate to inside the database. And I see one error here. So I had installment as an integer field, but if I look at installments, obviously that's a float field, so we're going to want to make sure we change that. Other than that, I think it looks good. Alright, so that's going to be our database model. So if we go back to our database, we can see all the tables. Ideally, what's going to happen is we're going to ask Django to go ahead and take this class that we've created and transfer that into the database and lay it out just how we want it. So in order to do that, we do kind of the same progression as we did when we initialized it. We'll go manage.py, and then we'll do make migrations, which will kind of prepare internally for it to go ahead and create that model. Then we get the OK there, so we'll again go manage.py, migrate, and just like that, we have created our database that should take all the data that we have. So that's the model we defined and was created. And if we actually want to look at it, there is the actual database created by Django without really having to know any SQL at all, which is again one of the nicer features and why it's so popular for data analytics, is because again you generally don't have to be a SQL professional to be able to manipulate databases, create databases, and analyze the data within them. Alright, so we have our database, which is fantastic. So now the next thing we need to do, the next thing we need to do is essentially get the data from the spreadsheet into the database. Ideally, when you're working on a project like this, you'll be tapping into an existing database, some sort of an application or some sort of a scenario where the data that you're looking for is already in the database. It's easiest to tap into it, kind of spit out a mirror of what the database already looks like and go right to town working on it. A lot of times you certainly won't be that lucky. You'll be getting a steady stream of CSVs or any number of other formats of data. So you need to be a little adaptable, which is what we're going to do with this. So what we're going to do is, in a minute here, is actually create a little Python function that's going to help us upload the data into the database, but that is also going to be relatively tedious at the end. So before we do that, we're going to touch on a couple other fundamental parts of Django, how it works, and set up some of the things that we're going to need to go along with getting this thing going. So I assume at least some of you are familiar with kind of the MVC framework. But for those of you not, so Django kind of works like this. Models are essentially a reference to the database. Inside here you'll have another file called views.py. This is going to be our view controller. This is how we're going to take a request incoming, an HTTP request, and then to that request we're going to return it something. In this case it'll be a web page. We can actually set up a view. So we'll need a few views when we get into it, into actually making the dashboard. We can kind of set frameworks for those. Oops. And actually what we'll do for now is we'll just set up one importer. We'll set up, we're just going to set up a view to, in this case all it's going to do is trigger our import function. In real life we'd build a little better uploader, but for this, this will just help us get a little bit of familiarity on how views work, and then we'll maybe build a little fancier uploader later. So basically the way views are going to work is we're just going to define a function. You can also do class-based views, and we'll touch on those a little bit later as well. Render to response. Okay, so what the view is going to do is it's going to take a request, which we'll direct via the URL file here in a second. Request is going to come in to a particular URL. URL file is going to tell Django to run a particular function in the view folder. The view, just obviously the name of the view, and then the incoming request. We're going to run any number of functions, and then we're going to return something to the response. Again, in this case we're going to return a web page, which we will build here in just a second, but you know, I think we'll just call it what should we call it? Let's call it test. Creative. Call it test.html for right now. So in our templates directory, we're going to create a new file, an HTML file called test, which we just specified. Title, let's call it test, and the body. Let's just do this. Sorry about the dog. We'll do. It worked. Essentially, what will happen is once it receives a request and attempts to render the response, everything in the function has to work before it'll actually render a response. So essentially, if we see the web page, we know that the functions the functions inside the actual view function actually ran. We can do a little demo of that here in just a second. Yes, this is PyCharm. Alright, so URLs. I'm going to add a URL here. So when we fire up our server, we're going to be looking at a particular location. In this case, we're going to call it import. Makes sense. And then we're basically just going to tell it which function to run, and that'll be that view that we just created called importer. So now when our site gets a request to this this address here, triggers this view, which right now all it would do is return the test HTML that we wrote, but we can go ahead and test to see if that's working, which it should be. So we'll start the little test server. Pull up a web browser. So because we don't have, because we're just going to the regular, what would be, as technically the root directory of the site, we don't have anything looking for a request at that location. We do get an error message, and we see this error message because we have the debug mode set on. But if we go to import, we see our little HTML page that we made there. Alright, so that stuff out of the way. Now, how do we get our data from said CSV file, this guy, into our SQL database? The short answer is that there's multiple ways you can do it. You could write a straight Python function that just inserts the data directly into SQL, which is probably going to be the most efficient method. However, it's not quite as reusable as some of the other methods out there. So I think we'll kind of write something that we'll use to pull it in. So what we're going to do is inside of our folder here, you import as CSV. Import what is CSV? What we're trying to do is we're trying to take the data from this CSV file and put it into our SQL database. So in order to do that through Django or through Python, we're just going to have to write a little import function to help us do that, and then we'll run that function right here. But to do that, we're going to create a new file. We'll call it, I guess, importer. Importer.py, that works. So we're going to need to bring a couple things in here before we get started. We're going to need the standard Python CSV library. And then we're also going to need a reference to our model that we built. I like to just bring it in as mod so I know what I'm referencing. So what are we going to do here? Alright, so we're going to start our function. Let's see, our creative name, let's go with get data. Then we're going to need the actual CSV file that we're pulling the data from. We'll take that as the input. file. How do I do this? Did we have a header in the data? So what we're doing here is we're going to look for the first row of the file that we're bringing in, which is going to be the header, and then we're just going to skip that. So then we'll pass down and actually start importing the first line of data, and we don't import the header into the database, which would throw everything off because it's not looking for those values. It's going to be looking for the integers and the floats and whatnot. Alright, so we're saying skip over the first row, and now for every other row, we're going to want to take that row and basically create an instance of the model class, which is going to get saved to the database. So it'll look basically like this: mod.loans, and then we're going to pass in the parameters here, and then we'll do the row.save, which will actually save each row from the CSV file into the database. This is again one of those parts that gets a bit tedious because at least for this, and there's other ways of doing it that are probably slightly easier, but just to give you kind of a foundational understanding of how it works, we'll kind of take the long way around for this particular bit right here. But essentially what we're going to do is, we know where the data is, and we just need to tell this function here where the data in the CSV correlates to the actual cells within the database that it's going to go into. So for example, we'd specify that loan amount is going to be equal to row 0. So that's the indices of the spreadsheet. So this is going to be row 0, row 1, row 2, row 3, row 4, so on. So again, this is going to be one of those tedious bits. It's going to take just a minute here, but once we get in, then we'll actually pull in the data and take a look at that. Oops. Anybody have any questions, comments, concerns, things you want to talk about while we kind of get this set up? It is an interesting process. Yeah, it's a bit tedious, and a bit, I guess, verbose at times. Again, there's a couple ways you can do it that's a little more streamlined, but for the purpose of this particular tutorial, it's probably good to know the long way around. Again, in an ideal situation, you have a database that you're just tapping into, or a data set that's a little more malleable or easier to just slide into a database rather than having to kind of go through this process. But once this process is up, it's pretty reusable. So let's say they generated this same CSV file every day, every week, whatever. You could really automate the uploading of it pretty quickly. The other good part is after we're done with this, most of the really tedious stuff is done, and then going forward, most of the stuff is a little more fun. Where are we at? State DTS. Almost. So here's our function. And again, all it's doing is taking the CSV file as an input. It's opening the file. It's using the standard CSV library to read the file. Then we use this row num here to detect the header, which is going to be the first row. Skip over that. And then after it skips the first row, for each line in the CSV file, it's going to create a new instance of our loans class, which is essentially a row in the database, and then it's going to save that row actually to the database. So let's get that going. So here's a file, throw it in here. And I'll also, like I said, I'll put all the code up on GitHub, and I'll also throw this file out somewhere that you can download if you do want to play along. So now we're going to go back to, I should get rid of this. So there's our function. I just kind of read over this real quick, make sure it looks good. Subgrade. That looks good. Let's give her a shot. Alright, so back to our views file. We're going to import the importer file. We'll do it as imp just to signify what it is. We'll add that to our function here. Get data, and now we need the CSV file. It should be here. Alright, so essentially if all goes as planned, we'll fire up our dev server here. We'll make a request to the web server, and then if we look inside of the actual SQL file here, oops, sorry, my dog's going nuts. Oops. Alright, so if we look inside of what's currently inside of our database, we have an empty set, which means there's no data in there. So once we run this, ideally it will put the data in there. And swing and a miss. Status is invalid keyword argument for this function. Alright, so we made a mistake here somewhere. Invalid keyword argument for this function. Loan status. Here, so that's wrong. Oh, I bet you we spelled it wrong. By we, I mean me. I misspelled status. Alright, part of the debugging process. Any good application has one. Alright, so let's see if that takes care of it. No, misspelled verification status too, I bet. Sure did. Never was a great speller. That one's cleared. Jesus Christ. I see what's going on. So balance. Best time 14.9%. Alright, so looks like we've got through the misspelling errors. This error here is essentially saying we declared a field an integer, and what it's getting is technically should be a character field. Let's see where we did that. Hello, Dimitri. So we'll check the model first, see if we can find it there. Sounds like interest rate. So here's the error in this field here. Looks like the revolving utilization. We declared it as an integer, but clearly that's not going to work in an integer field, so we just need to adjust that to accept variable character. Alright, fingers crossed, now we'll get some data. Oh, data trunk. Oh, okay, so what happened here is I made a change in the database model within Django. However, we still need to apply that to the actual database. And we use kind of the same method we use whenever we ask Django to make changes to the database. We just run the manage.py, make migrations to get everything prepared, and then assuming there's no errors, we'll go ahead and run the migration. Alright, so we've updated the database. I should probably restart the server. Alright, so big change between this error and the last error. So the last error, we cleared out all of our, I guess all of my typing, fat finger typing, and a couple of fields that we didn't declare properly. Right here, this error means we've actually run through and imported some of the spreadsheet into our database. So if you look here, we've got through 157 lines. And what's happening in this error is we're hitting a piece of data that just by looking at it kind of doesn't fit inside of the mold in which we thought it would be. Um, so we got through 157 rows before it kind of crashed out. What I'm going to do is I'm just going to delete these rows in here. So when we clear this one, hopefully we'll run through and finish importing the whole spreadsheet. But we don't want to duplicate the first 157 rows. So we'll just delete these out real quick. Dimitri, which program is that? Which program are you referring to? IDE is PyCharm by JetBrains. We're using Python as a programming language, Django as a web framework. This right here is MySQL. Alright, so we're back to an empty database. Let's take a look at this. Change to the database, and we do it the same way we just did the other one. Program that I use to type the code. It is PyCharm IDE by JetBrains. Lots of good ones out there. I've just been using this one forever, and it's what I like. Alright, so it sees our change on that field. Looks good. Run the migration, that's done. Alright, now fingers crossed, we should be okay now. Alright, so we'll make the request into our function. Alright, it looks like she's running like a champ now. So this is 100,000 lines. It's certainly going to take some time for all the data to get into the database. But we can peek over and check and see how it's progressing. So if we run the select again from the database, we can see so far it's populated about 4,000 rows. This thing froze. And Alright, so hopefully we'll get this sorted here and get all this data in. That's bizarre. I'm going to try importing this one more time. So weird. Here to get 5,000 rows into the import. So everything looks like it's importing okay at the moment. We'll give it a little more time. Again, with 100,000 rows, it's going to take some time to actually fully populate the database. So once we clear another 10-20,000 rows here, probably call it a night, so I can let the rest of it just sit and upload. Again, I'll throw all the code from today up on GitHub, so you can download it, play around with it, do whatever you like. I'll also link the file, the CSV file with all the data, so you can download that as well. Everybody uses WebStorm and JetBrains products. Yeah, I mean, they make good products. I think I started using them a few years back when Android Studio actually went over from it used to be Eclipse and then into the JetBrains platform, and then I really like the platform. And I'd played around with PyCharm a bit before that, but never really splurged for the license, and I think that spurred me to do it, and since then I honestly haven't turned back. They make great products. Yeah, we're still hitting this error here. So we're still getting an error. A string value for employee title that's just not agreeing with it. Alright, so let's see if we can find this. So it's occurring 5,797 rows in. See anything that jumps out as being an issue here. Not agreeing with it. Alright, so let's see if we can find this. So it's occurring 5,797 rows in. else puts her. Let's see anything that jumps out as being an issue here. I wonder if we missed something. Let's try this. I wonder if there's an open space or something that's. So we're just going to try adding a default value there in case that we're hitting just an open space and it's not recognizing it as a good string or something else like that's throwing it off. Alright, so we're going to delete the 5,000 that we had in there. We're going to start from scratch. Alright. Oops. That was a mistake. Alright, so about 4,000 rows in. So let's see if we can get past about 6,000, which is where the other error was. Alright. So we're still cooking here. I think we've sorted out all the bugs. The import seems to be going swimmingly at this point. Just to give you an idea of the time it's going to take, it's been run for about a minute or two now, and we are just shy of 10,000 rows in, so we have another 90-some thousand rows to go. So, so I think that's where we'll leave it for tonight. Again, we'll give this some time to go ahead and finish uploading. Barring any questions, anything else anybody is curious about, happy to answer here before I sign out for the night. Again, I'll load up all the code we did up on the GitHub. You can go ahead and download that. I'll throw the link on the project here in just a bit. And also a link to the data file that you can download. Looks like everything's running smoothly now. Looking good. Alright. Thanks everyone for watching. We'll get this out ASAP. Look forward to seeing you next week. And again, I think the bulk of the tedious stuff is done. And we'll go ahead and have a little bit more fun. Alright. So, I guess just a brief recap on what we did last week. We started out creating a new Python Django project. Went ahead and altered the settings file to attach to our local MySQL instance. From there, we took the data from this spreadsheet here. We looked at it, reviewed it, talked about it a little bit, and built this function and this model to go ahead and import all of that data into our SQL database, which looks like this now. So now we have all 99,381 rows from our spreadsheet put into our database. We also handled some miscellaneous stuff with URLs, views, and a little bit of HTML as well. If you guys want to play along, all the code from last week is up on GitHub. You can check it out via the link in the project page. The CSV file with all the data that we imported is in there as well. Also, just a heads up, we had to kind of alter the, I guess, curriculum schedule, as it were. We got a little bit further last week than I thought we would, so I've kind of updated the project page to reflect where we got last week. We did get a little bit more done than I thought we were going to. So the objectives for today's session is we're going to cover a few things. We're going to start with the ORM versus native SQL query discussion. So the first part is going to be more theory, Q&A, chit-chat. From there, we're going to move into a fairly brief review of Python data structures. So we'll take a look at the different data structures that are available in Python. Kind of look a little bit about what's unique about some of the individual ones, where they may come in handy, where they may not, and that'll kind of come into play a little bit later when we actually start building some of the actual business logic functions and math functions that are going to help us analyze the data. From there, we will kind of look at the spreadsheet again and talk a little bit about some of the things that we want to see out of the data, some things that may be interesting, some things that would seem directly related to the spreadsheet, and then maybe how we can use the data in that spreadsheet to maybe look at some things that you wouldn't necessarily look at correlating. We'll talk about that a little bit. And then after that, we'll actually go ahead and start building our business logic and math functions. And then we'll kind of see where that puts us for tonight. Next week, we'll kind of finish building all the business logic, math functions, things like that, and then work on passing that data to the view controller. I'm assuming we're actually going to start doing some visualizations next week too, since we're moving quite a bit ahead of schedule. Again, as always, definitely want this to be as interactive as possible. If you have any questions, comments, concerns, anything you just want to talk about, feel free and drop it in the comments, and we can drop it in the chat, and we can talk about it. So starting off today, the debate, the discussion about Django ORM versus actual physical SQL queries. So there's certainly advantages and disadvantages to each. As we learned last week, Django, many other languages allow us to build what are called ORM, or object relational mapping, which allow us to create basically a class or a model, or use Python code to allow us to build, manipulate, add data, subtract data, or do whatever we want essentially with the database. And we can do all that through Python. So on the surface, obviously that seems great. Being able to use 100% Python to do just about anything you'd ever want to do with a database, what could possibly be bad about that? So there's certainly pros and cons to both. So on the pro side, as we kind of touched on last week, one of the biggest is the fact that you can use your native programming language, in this case Python, but the same thing exists for Ruby and whatever language you want to go to. You can use your native skills in that language to, again, do anything you want to do with the database, analyze the data, stuff like that. So there's no need to be a certified DBA, no need to be a SQL expert, no need to learn multiple, different SQL syntaxes and things like that. So that's definitely advantage number one. Another pro to the ORM model is going to be security. With the ORM, it leaves out, or takes care of, I should say, a lot of little things that need to be considered when you're writing direct SQL queries, such as escaping strings and things like that could create potential security vulnerabilities if not done correctly. So that is another huge advantage of the ORM model. Third pro is going to be standardization. I guess it falls in line: standardization, database abstraction, or even agnosticism between databases. I can use this same model, and I can use the same code to call the data from the model. And if I change my backend from MySQL to Postgres, or even Microsoft SQL, or about any flavor of SQL you could ever dream of, I don't have to worry about changing any of the front end code or the back end code here, and that's a big deal in a lot of cases, especially in a situation where it may allow you to develop something using even like the built-in SQLite, transition that to a MySQL or a Postgres SQL database, and there's no need to change any of the syntax. It becomes very, very portable in that sense. So that can be a great advantage as well. I've even seen an odd occasion where they've replicated a program back into two separate databases of varying types, and then the ORM became more than a little handy in that situation. So it gives you that abstraction, that agnosticism, if you will, the ability to swap out back-end databases and not have to change the code at all. Another nice point, or another kind of pro to the ORM, if you will, is the way that it handles one-to-many relationships. It does it rather elegantly when you compare it to regular straight SQL queries, and the fact that it'll return you, nested objects, which makes it far, far easier to deal with than if you were just to write the SQL query for it. So before I get into kind of the last pro of the ORM, we'll get into the biggest con. Its single biggest limiting factor is going to be the speed at runtime. To use the ORM, you pay a performance tax, and you pay it in a big way in a lot of cases. So kind of back to the last pro. In some cases, where it's a fairly small set of data, more transactional in nature, it can actually be faster with the ORM just because of its ability to cache certain things that would otherwise be called repetitively from the database. But big picture, generally speaking, your native SQL queries are going to be anywhere from considerably to immensely to enormously faster, depending upon what kind of scale and what you're looking at in the database. And we'll touch on why exactly that is, kind of as we get more into what we're doing today, and we look at how we actually query the data using the ORM model and using Python functions, and then we'll kind of explain why the performance tax is what it is, and the difference between getting the same data via a native query. The other next advantage of using the direct SQL queries or native SQL queries is it just becomes a lot more versatile when you start getting into really complex queries. There's a lot more flexibility, a lot more, generally speaking, a lot more things you can do writing the native SQL over, the way you call the data with the ORM model, and we'll take a look at that as well. And then the ability to tune it for performance is even greater than using the ORM model. Once you get the native SQL queries built, you can look at some different things as far as tweaking the queries, or even stored procedures or different things to make that run even faster. So the long and short of it, the ORM, definitely easier to use. Get something prototype quickly. Not need to know much SQL or anything like that. But you pay the price in speed. And as you start to get into applications where you're talking about, tens of thousands, hundreds of thousands, or even millions of pieces of data that you're taking in and analyzing, it becomes pretty dramatic. A lot of times what will happen is you'll get applications prototype with the ORMs, and then as they grow, they get bigger, they hit production. You'll go back through and either refactor the ORM queries into native SQL queries, or look at something like a data access layer, or somewhat of a little more way to use code to directly reach specific SQL queries. I'm not entirely sure we'll have time to touch on data access layers and kind of some other ways that are midway between native SQL queries and the ORM model before the end of this project, but we're definitely ahead of schedule, so we might get there. So that's the ORM versus native SQL discussion. I hope you learned something and weren't bored to tears. So from there, we're going to go ahead and move into something a little more interesting. First thing I'm going to do in the project here is just go ahead and create a new Python file we're going to work with. I'm just going to call it logic.py, because this is eventually where we're going to start putting our business logic and our math functions and things like that. But for right now, we'll just use it as a bit of a blank canvas, if you will, to go ahead and review some of the native data structures in Python, kind of what differentiates them and things like that. Alright, so as far as data structures go in Python, there's really only a few different types. So you have a list, you have, let's do it this way. You have a list, you have a tuple, you have a set, a dictionary, and I guess technically speaking, a string would be a data structure, and we will just barely touch on that. So for starters, a list. In Python, a list is designated by the square brackets. A list is probably going to be one of your more flexible, most flexible data structures in Python. It tends to get used a lot because of that flexibility. Inside the list can house anything from numbers to strings to other lists to about anything else you want to put in there. They're very flexible in that sense. Another thing about lists is just like about everything else in Python, they are objects. They do have a number of methods associated with them that can be quite useful. We'll cover a lot of those here today as we start getting into everything. But as far as just kind of the general, definition, list very flexible as far as a data structure. So you have a tuple. So a tuple is very much like a list, with the difference being that a tuple is immutable, which basically means once you create the tuple, it's more or less going to remain the same. There's very little that can be done to change items or orders or anything like that within the tuple. So for example, with a list, you could use a method like sort and sort the elements within the list. With a tuple, that's not an option. So it certainly lends some pros, some cons. So as far as a tuple, it's immutable. One of the pros to a tuple is, generally speaking, Python's going to process it faster than a list, and it does that because it knows where to expect the data, and there's again zero. I shouldn't say zero. I'll cover the one instance where data can really change inside a tuple, but for the most part, data inside the tuple is going to be unchanged. Another nice thing about it is it makes it good for protecting data. So if you come up with a set of data that you want to transfer to different parts of the program, but you don't want to worry about data inside the structure shifting, tuple is great for that. And I said tuple is immutable. The one time you can worry about data inside a tuple shifting would be a situation like this, where you have a mutable object in this list inside your tuple. So this isn't going to change. However, the 4 and the 5 could change, or anything inside this list could change because the list itself is mutable. But this list will always be in the same position within the tuple, if that makes sense. I hope that makes sense. So tuple, great. Again, this is by no means supposed to be, an exhaustive definition or in-depth dive into the different data structures. I just kind of want to touch on them a little bit before we actually get into using them. So if you see them in the code, they kind of make sense what we're doing. If at any time they don't, feel free and let me know. Our third data structure, I should say, is going to be a dictionary. Dictionary is going to be pretty similar to a dictionary in any other language, just like a list is pretty similar to an array in about any other language. So the dictionary is just going to store key value pairs. So you're going to have a key, and then you're going to have a value, which, whatever. And then so on and so on. You'll have multiple keys, multiple values. Typically, dictionary is not sorted or ordered. It really doesn't have a concept of order. So anything is pretty much going to have to be referenced by key. The other thing you'll need to remember with a dictionary in Python is keys need to be unique. So if you were to try and create another value for a key of my key inside the dictionary, you're going to run into problems there. So that's something to keep in mind. The last, well, I guess not the last data structure, but another type of data structure which we probably won't touch on much in this particular tutorial is going to be a set. So a set in Python kind of uses this syntax to declare it. Oops. One of the things with a set is, so essentially what a set is, it's a, I don't know how to describe this. It's essentially an unordered list, but it's not a list. So an unordered set of unique characters. So you cannot have, let's say, a duplicate value within a set. So a lot of times you'll see it used in testing for membership, or using it to remove duplicate elements from some sort of a sequence. The last type of data structure, and again, we won't really probably touch on sets too much in this tutorial, but if we do, I'll make sure to certainly point it out. And the last type of data structure technically is a string. String is just essentially, a random string of characters. The syntax is obviously the quotation marks. You can use single, you can use double. There's a whole lot of methods that can apply, but I don't think we need to get real heavy into that for what it is we're looking today. So those are more or less the basic data structures. In what we do here in this tutorial, you're going to see a lot of lists. You're going to see some tuples. You probably see some dictionaries. Obviously, you'll see some strings, but sets I don't know what we'll touch a whole lot on. So we probably don't need to spend too much time reviewing that. So that being said, that's our quick data structure remove, or quick data structure refresher. Anybody have any questions or anything like that? Let's see. Hi, do you have experience in deploying Django applications to DigitalOcean? Yeah, I've used DigitalOcean VPSs before to deploy Django applications. It's really similar to any other VPS or similar platform you're going to use, whether it's AWS or whatever. It's pretty much the same straightforward process. Trying to think if I have any videos or tutorials on here. If you dig through my old videos, I might have a video about setting up a project on AWS. I don't recall off the top of my head, though. Alright, so we've touched on data structures. Alright, so next thing we need to do is go back to our spreadsheet. Let's take a moment for it to load. Alright. So if you guys remember our spreadsheet here, which now is inserted into our database, the next step is we got to take a look at this, and we need to determine what we want to see from this data, what correlations make sense to look at, what might be interesting to see, how they relate to each other. In a business scenario, you're generally going to be looking for, business problems you can solve by looking at the data. But since we're not directly in a, I guess we could play that way. Yeah. Anyway, we'll look at just interesting things we can make from the data. Can I please help? I can't at the. Okay, so you're having an error while deploying. I generally would say no while I'm streaming, but let's take a peek. I'm looking at the air. Honestly, on the top of my head, I don't know. I'd have to jump in and take a look. But if you want to direct message me or something, possibly after the stream or something, we can take a look or get together and see if we can offer you a little more insight on that. But back to the project at hand, looking at the data. So if anybody can think of anything, has anything they'd like to see, feel free to throw it out. I can tell you just from me, kind of looking at this for a few minutes, what I thought might be interesting. And then we can, discuss if there's anything different you guys want to see or whatever. So I know one thing I thought might be, interesting to look at would be, average loan amount as it pertains to credit grade. Are people with larger loans tending to be higher credit, or people with maybe lower grades taking out higher loans? Just trying to see if there's any relationship or correlation between those. I thought that might be interesting to look at. Along those same lines, I thought it might be interesting to look at, interest rate versus credit grade. Obviously, you're going to tend to see lower interest rates on the better credit grade, but maybe there's somewhere along that scale that's slightly disproportionate that may be interesting. Also, we could look at something like the average installment payment, either determined by credit grade or employment length or home ownership. Even annual income to see, if there's any correlation between any of those. Loan amount versus annual income, credit grade versus home ownership, or even maybe employment length versus home ownership. I'm curious to look at, it's one of those kind of non-traditional things. So when you're looking at all this financial data, you're going to be expecting most of the time to be looking at things like loan amount and interest rate, and credit grade, and how those things correlate together, even into the other columns as well. So how loan amount and interest rate correlate with a job title or employment length or home ownership. But this is one of those things you can take data sets and look at kind of correlations that may be outside what you would primarily think you're going to be using the data for. So for instance, we have 100,000 records of people borrowing money from all, assumably all walks of life, from A credit grades all the way down to E credit grades at 25% interest. So you imagine it's a pretty wide swath of people, a pretty good, solid, robust data set. So you'd think if you compared employment length to home ownership, the result of that would probably be a pretty reasonable correlation. So I'd be curious if people who have been employed longer tends to be more homeowners with, as opposed to people with shorter employment histories, tends to be more renters. That could be the case. It could totally not be the case. There could be no correlation at all. It could be all over the board. But, I think it might be an interesting thing to take a look at. So those are kind of the things that jumped out to me as things that we could not only take a look at, do the analytics for, but also should make some fairly interesting visualizations and graphs and charts and things like that. Depending upon how much time we have, one thing I would like to do, and even if we have to extend this out an extra session, is going to be doing some analytics by geolocation. So we'll take, I don't know if we can work with the first 3 digits of the zip code, but we might be able to, at least on some level, get some geolocation from that. But at least we have the states here too, so we can do some visualizations using maps and things like that, which are always cool. So I guess, like I said, if you guys come up with anything you specifically want to see from the data, you think it'd be cool to look at, you want to see the code for, just feel free to throw it in the chat, shoot me a message, whatever you want to do there, and we'll certainly take a look at it. Again, we definitely want this to be as interactive as possible. So if there's things you guys want to see or not seeing, make sure you throw it out there for sure. Again, just a reminder, all the code from this project is up on GitHub. You can download everything we got through last week, as well as the original data set. Then once we get through the session today, I'll upload all the new stuff to that same GitHub link that's on the project page. So I guess at this point, we're moving along quite well, and I think it's time to start writing some code, huh? So what we're going to do is start laying down the business logic and the math functions to extract some data to get our first kind of analytic set, and move from there. Alright, so what I did was I created a new blank file inside of our dashboard directory. This file is called logic.py. It's a pretty standard naming convention, at least for me. I tend to name a lot of my logic files logic.py just because it makes sense. First thing we need to do to kind of get things going is import a reference to our ORM model that we made last week. So we're just going to import that file, and we're going to import it as mod, just so we know when we're referencing a class out of that file. So what should we do first? Anybody throw anything out there? Nada. Alright, so nobody threw anything out there, so I guess it's my choice. So I guess for starters, let's look and see if we can see if there's any correlation between the average loan amount and a credit grade. That kind of gives us a nice range of data to work with and a couple of good examples to make. So we're gonna do loan amount, if I could type, versus credit grade, and see what type of correlation that we can pull from there. Alright, so the first thing that we're going to need is we're going to need a class. So we're going to need an object to store our data as we move it throughout the program. And what we'll do is we'll define an object that is going to be structured to hold the data that we're expecting. We can always modify that as we go, but just to get it started, let's call this, I'll call it grade versus. Alright, so we're going to call this class grade versus because we're going to look at credit grade versus another property. Now we could call it, whatever, loan amount versus credit grade versus loan amount. But we're going to leave it slightly open-ended, and I'll show you why when we kind of circle back at the end. But we'll talk about, reusability and stuff like that here in a minute, and the whole thing will make sense, I promise. So we go ahead, we named our class, then we're going to go ahead and give it an init method. Alright, So basically, we're saying, inside the class, we're creating a new object. That object is self. Now we could basically leave it as this, and we could define the parameters that we're looking for as we go. However, just to make it a little bit easier as far as when we create our data set, create our object, we're just going to go ahead and specify the inputs that we're looking for here. So basically what we're doing is we're initializing a new instance of the object. We're creating itself, and then we're looking for inputs. So in this case, it's going to be credit grade A, B, C, D, and E. Now, this is actually probably a terrible naming convention as far as teaching. Do this. Alright, this is a little better. So we'll do, grade A equals A. If you can't guess, we'll do B equals B. And I'll explain in just a second why we're setting it up as we are. Okay, so what we're going to be doing is as we go through the math functions and as we're creating our object that's going to transfer this data throughout our program, the object we're looking for is going to need to take really two pieces of data for each data point, or each loan grade, I should say. So for grade A, we're going to need to know the average loan amount for grade A, and then we're going to need to know the total number of loans for grade A. We're going to need that same thing for grade B, C, D, and E. So one thing we could have done is doing something like this, where we did an input for A and A1. So something like amount. Alright, so we could have done something like this where we're taking a parameter. So we do grade A, so say this would be the number of loans in credit grade A, and then this value here would be the total loan amount of all the loans in grade A. So we do need those two pieces of data in order to do our analytics and our visualization at the end. But instead of doing it that way, what we're going to do is we're going to impart one of the data structures that we learned before, called a tuple. And essentially what we're going to do is, so for grade A, we're going to bring in a value that's going to be a tuple, where this is going to be the total loan amount, and the second value in that tuple will be the number of loans. So we'll have both of these values in one property, and then we'll be able to access those as we go, if that makes sense. So that's why we're so it cuts down basically the inputs we need from 10 to 5. And we could probably cut it down even less, but then we start losing some of the reusability that's going to exist, in this class, and in kind of the functions that'll be coming after it. All right, so now we have a place where we can put the data, or a data structure that's going to carry the data, an object that's going to be created to house the data we get. So Now we actually need to get those values out of our data set and into that object. So what we're going to do is we're going to create a function to do that. We'll call the function grade average. So even though, again, we're looking at, I'm going to redo this here. So even though, again, we're looking at going to be the credit grade versus the loan amount, we're going to take a look at how we can reuse a lot of these functions and how we can change some of these to be able to get a variety of different number sets based on the parameters that we pass to the functions. One thing I should mention up here, this name is fine, but as far as kind of a general best practice, if you will, if you really want to kind of look at the standardization of conventions in Python. When you name a class, typically it's going to use camel case versus kind of the underscore, all lowercase that you'd use in functions. Just something to keep in mind. It honestly doesn't make any difference other than it's considered a best practice, and it makes it a little bit easier to read when people are looking at your code. Alright, so we have the start of a function here. So in this function we're going to need some data. In this case it's going to be a query set. We're going to leave that kind of open-ended at the moment, so we're just going to say, function, you're going to expect some data. With that data, we want you to do the following, and we'll define what that data is in our view controller here in just a little bit. So we have our function expecting some data. Now, inside of the function, the first thing we're going to need to do is if we think about what we're doing, we're going to be looking through the data. We're going to be pulling out basically all of the loans, I guess. So everything's going to fall between credit grade A and credit grade E. So what we're going to do is we're going to go line by line through all of the data. And if it's a credit grade of A, we're going to stick it into a container with all the other A's. If it's a B, we're going to stick it through B. So essentially what we're going to try and do is sort all of the loans via credit grade into their own bucket. So the first thing we need to do is create the buckets. So we'll just call them by loan A, B, C, D, E. Alright, so loan A, B, C, D, E. So these are going to be our buckets, and they're all going to be lists. So what we're just going to do is specify that here. Alright, so there we go. So we've created or basically initialize 1, 2, 3, 4, 5 buckets that are going to correspond to our different loan grades. So now what we need to do is we need to loop through this data, and we need to determine what grade each line is, and then take that loan amount and put it into one of the buckets. So this is a really simple for loop for Python. So we're just going to say for I in data, I is just a variable. This could be anything. It could be X. It could be row, because it's technically looking at a row in the data. So we'll call it row because that I think is probably a little more descriptive word. So for each row in the data, we're going to go ahead and look for the credit grade. So we're going to say if row.grade, which is what we specified the credit grade as here, if you remember in our model. So we called it grade. So we're going to say if row.grade, which is a credit grade, is equal to A, which is how it's represented in the database, do the following. And the following is we're going to take that first bucket, loan A, and we're going to use the append method. So this is one of those methods that's available to lists. We're going to use the append method. So basically we're going to take loan A and append it to the bucket. So basically we're just adding loan A to that bucket. There is another method very similar to append called extend. If you guys are really curious about that, I can explain it. But it really comes into play mainly when you're trying to, say you're trying to add a list of objects to an existing list, but didn't want to, but only wanted to insert the objects, not the actual list object. I can get more in depth if you guys want to see it, but just be aware there's another function called extend that's slightly different. So what we want to do is we want to append row loan amount. I think we defined it as loan amount like that. Loan amount, yeah, okay. So again in the function, all we're doing is we're looking to see if the row in the data, if the credit grade is equal to A. If it is, we're going to go ahead and append the loan amount to our A bucket. Pretty easy, pretty straightforward. And then we're just going to kind of iterate and say if the grade isn't A, then let's look and see if it's a B. And if it's a B, we're going to do the same thing that we did to A. We're going to go ahead and append the loan amount to the B bucket. And then we're going to do the same thing all the way down. So we're going to look, if it's not an A or a B, we're going to look to see if it's a C. And similarly, append the loan amount. Wow, I'm having problems tonight. Alright, so here we have it. Thorvald, Python is great. Yes, it is. Alright, so again, for the 15th time to reiterate the function, what we're doing is we're looking for a set of data to come into the function. We're saying that there's going to be 5 buckets, loan A, B, C, D, and E. We're going to check each row of the data, which is going to correspond to each row of the database. We're going to look and we're going to say, is the credit grade A? If it is, we're going to append it to A. If not, is it B? We're going to append it to C. If not, C, append it to C, D, E, so on. Okay, so now what we have in the event everything works as directed, as expected, we'll have these 5 buckets here filled with loan amounts. So remember when I said we need 2 pieces of data? We need the average loan amount, and then we need the total number of loans. So we're going to use some operators in Python that work with loans to go ahead and help us get those from these buckets or these lists. So there's a fairly there's a fair amount of ways to do this. To be honest, we could just go ahead return a new instance of this class right here, and it would have all the data that we need. But we're going to take a look at a couple of different ways we can do that. So instead of just returning the data, we're going to say our data for return data. This is the data that we want to return back at the end of the function. Is going to be a new instance of this class right here. So we're going to declare that and then signify here where the inputs are going to go. And we're going to talk about the inputs here in a second. We're going to give us an obligatory print function so we can look at that data that we create, and then we're actually going to return that data. So these three steps don't necessarily need to occur. We could just jump, replace this our data with return, and it gets the same place. But this is going to help us look at the data a little bit as we look at how we declare it, how we move it, and things like that. So, how do we want to get this data, into there? So we've went ahead and declared the new class, and now we need to start putting in the data. So what it's expecting, it's initialized itself, so now it's expecting these inputs here, and we've already talked about the inputs should look like that. So how do we get this from our lists? So if we wanted to do an average loan amount, we would do two things. So we would use the sum method or function, and we would say, let's take the sum of our first bucket, loan A, and then divide that by the amount of entries in that same list, which is also, loan A. So if you take the total of all the values added up together, you divide it by the number of entries in that list, you get the average. So this here would get us the average loan amount of all loans with an A credit grade. So to make things slightly more confusing, because we are doing this as a tuple, we need more parentheses, another one there, we have a comma, and we'd essentially do the same, and then we'd actually just do length of loan A. Oops. Alright, so this right here would get us our first input of A, and would get us this right here. So we have a tuple, we have the two outside brackets or parentheses, and then you have this right here, which gives you the average loan amount, and then you have the total number of entries. We could go ahead and do this all the way through, loans A, B, C, D, E, and it would work just fine. It would get us the values that we need. It would get us the data to go, over to our view that we could then visualize. But we're going to come across probably more than one scenario where we're going to need to find the average of particular lists like this. So one of the things that we can do to help us out or make this a little more readable is just make a quick little helper function that takes some of the complexity out of the way we need to pass the values to our instance of our class up there. So what we can do is just quick make a little helper function that's just going to look for a input of a list, and then we can just say all it's going to do is return a sum of that list divided by the length more correct. Actually, I guess we don't need to do that. All right. So we made a little helper function. All it does is takes a list and essentially returns the average of it. That's all it does. But then instead of kind of getting this semi-confusing entry here, we can cut that down to loan. So that just makes it a little bit easier to read. So again, we still have this exact same thing, end result happening here. We're getting the average of that first bucket, the average loan amount, and then we're getting the total amount of loans in credit grade A. So essentially we're just going to continue that sequence on to the rest of the grades. So we have C. Alright, just kind of working out some of the formatting here and make sure we have the right amount of parentheses set in our function here. Alright. Alright, so we're taking our data from our individual loan buckets. We're taking the average loan amount and then the total number of loans for each credit grade and generating an instance of this object here. And then really, I guess the last thing to do, or kind of where we'll go for tonight, is we'll go ahead and just look at the data that we have created just to show you that it works. So what we'll do is we'll create a little view called test just to trigger this function, so we can go ahead and verify that we're getting the data that we think we should be getting. We need a new URL. So we'll just call the URL test. Run the view. Alright, so if we just simply print our data, it's just going to show us that we have an instance of this class. But yeah, we can do that just to show it else. So alright, so then the last thing we need to do is in our views file. Actually, any sort of characteristic of any of the columns that are in the database table. Hey Dimitri, how are you doing, man? So we can use filter to filter or cut down the query set by any value in any of the columns. There's a whole lot of different things that we can filter by, but in this case, because we want all the objects in the database, we can just use the all function. And that'll give us all of the records in this database table. So we're just looking for this table, and then objects, and then which objects. We just want them all. So our data set is going to be the query, or our data is going to be the query set that gets returned from this, which is essentially just all the data in our data table. If you're going to write it as a native SQL query, it would basically equate to this. I mean, this is essentially what it equates to. So it's just saying, give us all the data in the database, or in this database table, and then give it all back to us as this data set. So now that we have that data, we can go ahead and call the function that we wrote after we import it. So we're going to import our logic file. We'll call it logic, or log. So this is our function that we created to get the data. Now it's expecting data, which we'll go ahead and pass it as this query set. And then what will happen is if we go to the test URL, it'll trigger this function to run. I guess what we'll do though is we'll go back to our file. So instead of just printing our data, which is essentially going to just give us, it's going to basically say, instance of object return. It's not going to really give us a whole lot of data. What we can do is we can specify that we want to see grade A. So what we're saying is, of the instance of this class that's being returned, I want to see the data for grade A. So in theory, it should give us the tuple that we set forth. That'll have the average loan amount and then the total number of loans within the the set there. So let's just fire up the server. We'll go to our test URL. Now notice, excuse me, notice the time that this takes to complete. It went through 100,000 lines, and again, you're paying a data tax, so that lag was the amount of time it took to run through all those 100,000s. If we would have just went with the native SQL query there, it would have been much, much quicker. Dimitri, Python is not that easy. I know C# and can't understand the code on the screen. I think Python, at least to me, came super easy to learn. The biggest struggle for me, and I came from Java when I went to Python originally, or learned Python originally. I was coming mainly from a Java background, and the biggest thing for me was getting used to the white space. But once you get used to the white space, man, it just reads so easy. I've really, really become fond of it. But if we look here, this is our print statement right here. So we're getting an average loan amount for A credit grades of $14,057. And that's based off a total of 15,359 loans. So I mean, we can be pretty sure that the rest of our data is working as well. We'll call B just to maybe take a look at it, but again, I'm gonna go ahead. I'm gonna refresh this. It's gonna make the query again. But definitely pay attention to the time that it takes this to actually fetch that data. Again, it's for 100,000 lines, it's not that bad. For some people, it certainly might be stomachable. But there's certainly a bit of delay there while the ORM runs through it, as opposed to just the native query. So if we go back, so here's our B data. We have an average loan amount of 13,217 loans based on 29,521 loans. So what we've managed to do is go ahead and create a function that gets us the data we're looking for, so we'd be able to make a visualization to see exactly what the correlation between loan amount and credit grade is. I think this is going to be excuse me. I think this is kind of where we're going to leave it for tonight. I think we made some pretty good progress today. Next week is going to be a lot more code and a lot less theory. I hope this was certainly helpful to some people out there. I don't know what I just did there. I hope it was helpful to some people out there, but at least you should be able to start to see how we're going about parsing the data in the database, getting it into getting the data that we need from the database, and then structuring it in a sense that we'll be able to use it in the next step to render some pretty good visuals and really easily be able to see the correlation between these different things. So when we come back next week, we'll do a couple more functions and classes like this to get some more data to go ahead and visualize. And then we're going to start making some visualizations, which should be pretty cool. Between now and then, I'm going to go ahead and upload all the code we did here today onto the GitHub. So if you want to download that, certainly feel free. Other than that, if you happen to be watching this as a video, whatever, you have any comments, need anything from me, just feel free to, shoot me a message. I'm pretty diligent about checking them. Other than that, I just want to thank everybody for checking in today. I certainly welcome any comments, criticisms, feedback, anything you want to see in future sessions, anything at all, really. Feel free to hit me up. Let me know how I'm doing. But again, thanks everybody. Good night, and we'll catch you next week. So last week we went ahead and we started building the functions that are going to help us actually analyze the data from within our database. We got the first one done here, so what we're looking at is average loan amount by credit grade. So I think today what we're going to try and do is get through the rest of our functions to help us get the data from the database into a format that we want to look at, and then we're going to cover a little bit on how we pass the data, from our program through the Django templating system into our HTML, and then once we get there, I think we're probably going to call it a session for the night, and then we'll save starting the visualizations for next week. Thorvald, hey, how's it going, man? How you doing tonight? Alright, so let's get going. So again, the first function or the first bit of data we're looking at here is going to be the average loan amount by credit grade. Along those similar lines, one of the things I was thinking might be interested to see would be interest rate, and doing that by loan amount or by credit grade. Couple of ways we can go about doing that. So we'll get that set up. Then we'll pick one or two other relationships we want to look at, and we'll build those functions quick. So I think first thing we want to do is, so if we look at our spreadsheet, or I guess we could look at the database too, but the spreadsheet's going to be a little bit easier to read for the time being. We have interest rate here, and we want to look at that by credit grade. So when you think about getting that data, it's very similar to what we're doing here, right? So we're pulling all the data, we're looping through each row, we're looking at what the credit grade is, and then we're going to need to pull the interest rates and store them temporarily until we create another instance of this object right here. So this object right here, just as it works to hold the data from loan amount versus credit grade. That's bizarre. Oops, sorry about that. So just as we're going through the same function here, we want to do the same thing to pull out interest rates. So there's a couple of ways we could go about it. One is we could basically copy the same function, change row.loan amount to row.credit grade, or I'm sorry, interest rate, and more or less it's going to give us the same object that we need. Obviously, for that small of a change, it probably doesn't pay to rewrite the entire function. There's some cleaner and simpler ways we can do it. One way would be to add another parameter to this function. So say we could go something like this. where this is going to be loan amount or interest rate. So we could change all these to be this parameter, and then when we call this function from our views file, we could pass it loan amount, and then we could this would be a string here, and then we could call it again. So we call it once for loan amount, and then we call the same function and then pass it interest rate. So it'd be we would end up passing it the same thing, and then we'd pass it. We'd call it again, pass it interest rate. So typically in Python, that type of reusability in functions is what you're going after. To be able to get the most things done with the smallest amount of functions typically makes for the simplest program. However, there's a big downside in that type of mentality versus another way to go about it, which we'll look at. So instead of doing that, which in conventional programming would probably be the way you'd want to go, the issue with it is when you look at the vast amount of data that we're looking at here, so every time we run this function, we're having to loop through 100,000 rows of data. And you can imagine if you're working on a program that has millions upon millions of rows, to have to call and loop through that data multiple times is going to cause the program to become very, very slow. So the easiest way to get what we need, and again, this isn't the most reusable. This definitely isn't necessarily a best practice as it comes to Python programming. However, when we look at efficiency, this is definitely going to be the most efficient way to get the data we want. So in order to get the comparison of credit grade to interest rate, we're just going to kind of add on to this function here. So in a very similar way to the fact that we need these buckets here to store the loan amounts for each credit grade, we're going to need the same buckets to store the interest rate for each credit grade. So we're going to go ahead and declare our buckets, our lists. Alright, so now we have a second set of lists here, and then we're just going to kind of use the function that already exists. So as long as we're already going through the data once, we're going to say, if the credit grade's A, first we want the loan amount, and then we're also going to want the interest rate. And then what did we label interest rate here as int rate? Good evening, in Seattle. How you doing? All right. So then we're just going to kind of move this down throughout the program. So now, at the same time that we're looping through the data to go ahead and add our loan amounts to our buckets, we've created the new buckets. Now we're going to add the interest rates too. So the benefit, again, of doing it this way versus the other way we talked about is we're still only looping through the data once. So we're going through 100,000 rows, but we're only doing it once. If we went the other way where we actually had to call the function twice, then we'd be going through essentially 200,000 rows because we're going to be doing the same 100,000 rows twice. And then as we build, more functions, as that extrapolates, the performance tax your program is going to hit is going to be pretty immense. So again, just one of those things to remember. It's not necessarily a best practice as far as Python programming goes, but as far as efficiency and getting through the data, it's definitely going to be much faster. So now we have the interest rates in our buckets, and we need to generate another instance of an object to help us move that data across in a structured manner. Now this class that we built up here, we can use it just the same as we did for the loan amount. A bit of one thing we do have to contend with here. I'll pull this spreadsheet back up. So one thing that may give us an issue is when we look at interest rate, as we pull this out of the database, there's going to be a percentage sign attached to it. So at some point we gotta go ahead and figure out how we're going to strip that out. So we'll probably just go ahead and we'll write ourselves another little helper function here to pull that out and make sure we have the right type of a value that we're going to get back. So we'll call this our data. Alright, so we'll call that loan amount data. And we'll call this int data for the interest rate. So again, we're going to want to start a new instance of this class. Thorvald, they're using Django here. Yeah, we are using Django. So far, everything we've looked at to this point, is all Python Django. If you're curious, this is the model we made in the first class. I'll have all the code and all the data files linked in the project page when we're done here tonight. So if you want to download and check it out, certainly do so. All right. So before we get too much further, let's figure out how we're going to go ahead and get rid of that pesky percentage sign. Alright, so we're going to start a little function that's going to expect a list to come into it. And then we'll take, how do we want to do this? So actually maybe we'll strip it out before we append it into our lists here. And then that's going to simplify when we go to get the averages. So instead of a list, we're going to be expecting It's technically going to, I think, come out of the database as a string, so we're going to say, whatever. It's going to be a value with the percentage symbol, but, this just represents whatever's coming into the function. So we're going to take whatever gets passed into the function, and then we're going to go ahead and split at the percent sign. So this is one of the string operators. I think we might have briefly touched on it last week. So what we're doing is we're taking in the interest rate, we're going through the digits. As soon as we see the percentage sign, we're calling the split function, which is going to take everything prior to the percentage sign and split it off into its own entity, and then we'll call that whatever. Alright. Alright, so we don't want to call it alright, so again, we're taking the number that we put in, stripping off the percentage sign, and then returning just the number. So then we'll go here where we're going to append it into the row, and then we're just going to call the percent remover function that we made on it, and then hopefully that should take care of our issue with the percent sign. Alright, so now that we have dealt with the pesky percentage sign throwing us off, we can go ahead with building the instance of our class. We're going to use the same average helper function that we built for the loan amounts to help us get the average interest rate for each credit grade. So we're going to call average helper interest A. And then we will also, that's going to give us our first value, which is going to be the average of all the interest rates in credit grade A. And then we also need the total number of interest rates that we're looking at here, the total number of loans. So then we're just going to call len to give us the length of the list, which gives us the number of loans in the list of that same bucket there. And we're going to go ahead and do this all the way through. We'll do a little copy paste magic here to help this go a little quicker. If anybody has any questions, comments, anything you want to talk about, feel free to chime in. We're missing some outer brackets on our tuples here. All right. So just like we did for the loan amount data, we've taken the interest rate data across all the different loan grades. We've got the average as well as the total number in each grade. And then we need to now decide how we're going to return the data. Since we've been using tuples, I think we'll just use another one here. So we'll call it data, int data. So we'll return it like so. Now we need to go over to our views file. So now if we're looking at data, we're going to have to name this guy. So this will be shit. Alright, so we're moving over to the view controller. This is again where we respond to an incoming request via one of the URLs, which triggers this function to run and then returns a response. In this case, it's still our test HTML. So again, this right here, this first statement here is just saying data is equal to the sorry, my dog is going crazy over here. So what we're doing is we're calling from our loans table in our database, and we're just taking all the objects from that database and then passing it into that function that we just built. And then return data is going to be equal to this data right here that we're generating at the end of our function. Alright, so we have those bits of data. Anybody else have any suggestions on what you want to see as far as any calculations or any comparison to any of the data on our spreadsheet? Some other things I thought about doing, we could look at average interest rate by home ownership. If we want to look at loan amount versus annual income, we could look at credit grade and home ownership, or employment length. Let's continue. Yep, we'll get her moving here. Just trying to decide what we should look at next. We're gonna need some more data before we start doing the visualizations. The two that we have are going to be a little weak, so we definitely need at least one more data set to look at. I'm thinking let's do loan amount and annual income. See if that that has a correlation. What does income look like here? Yeah, that's a pretty fair value. Okay, yeah, let's do that. Alright, so in order to look at, to see if there's any correlation between loan amounts and annual incomes, what we're going to need to do is, again, create a function to help us get that data out of the database. So we're in this function, we're taking a look at 5 different credit grades, and we want to see how interest rates compare across all 5. Same with interest rates and loan amounts. So that we needed 5 buckets, one for each loan amount for each thing that we're looking at. In this case, because we're looking at more of a one-to-one Max, no. Because we're looking at more of a one-to-one relationship, what we're going to do is we're going to pull all of the loan amount and income data out of the database, and then we're going to just insert them as tuples into one list, and then we'll process the list before we do the visualizations. So if you guys remember, we declared a spot to put our data. So now we're going to take a look at the data, and we're going to do a loop very similar to this guy right here. And actually we could append this into this, which actually let's do it that way. So back to when we were talking about performance versus best practices. Again, in normal programming, you'd probably start a separate function for this because it's different enough that it probably warrants it. But in regard to our program here, we're trying to minimize the amount of time that we need to call the data from the database. So as long as we're already looping through the data here once, we can certainly add it to this function in the interest of speed. Again, so instead of having to go through the 100,000 rows of data that we have, or potentially millions of data in a real-life database, instead of having to go through those multiple times, we can do it within the same function. Again, it's probably not the best construct by the book, but it's certainly going to be the most efficient. So in this case, we don't really care about credit grade. So we're going to kind of catch this loop before we get to that point. So basically we're going to say for every row we're going to need another container here. What did we call annual income in our model? Alright, and it was essentially that easy. So now what we're doing is, as we're going to loop through the data for these other fields that we're looking at, before we start comparing the credit grades for every row, we're simply going to append the loan amount and the annual income into this list here in the form of a tuple. And then That'll give us a list of every load amount and income, and then depending upon how we decide to do visualization, we might do like a plot chart with that. We can do some bar graphs. We can do a couple of things with that. So that'll give us a one-to-one. We have the one-to-many. So that should give us a pretty decent variety of charts and graphs and things that we can build with this stuff. We'll also have to return it in the function. All right. So we kill this print statement. Whoops. Thank God for Control Z. Greatest thing ever. File a bit. Anybody have any questions about our function here and how we're getting the data, what we're looking at? Okay, moving on. Alright, so the next thing we're going to look at is going to be how we take this data that we're getting back from our function and then how we actually pass that through to our HTML view when it renders. So this will be the last thing I think we touch on tonight, and then we'll save the visualization stuff for next week, because that'll be, then we can do as one full segment with just the visualizations, which I think will work better. So Python and Django uses a templating system in order to get data from the back end of the program out into the front end of the program, or the actual HTML. So right here we have this return data, which is the values that we're returning from our function here. So what we need to do is get that out into our test.html files. Okay. So in our response, so again, request comes into a URL. urls.py file determines which function to trigger. Triggers the function, does whatever we tell it to do inside the function, and then eventually returns an HTTP response back to the browser that made the request. So right now in our response, all we're specifying that we're returning to the browser is going to be the test.html file, which we made real briefly, I think, in the first week. So we're just saying this is what we're returning back. Pretty easy. We can add whatever data we want here that we're also going to pass through to the file. So the first parameter it's going to take is going to be what the template is going to reference it as. In this case, we'll just call it data to keep it easy. Although, not to get confused with this data right here. We'll call it web data. And then the second parameter is just going to be what exactly is web data, which in this case is the variable we named return data. So all we're doing is we're binding this variable to this templating keyword, and we're saying we're going to pass this out into our HTML template. And you can say we had some different functions that we run, and then we had 3 or 4 different variables that were like return data with different data inside of them. You can just keep adding key value pairs to the dictionary, binding whatever data you want to pass through. So as we get into the actual HTML, I guess kind of a brief tutorial on templating language. So to reference values inside of the dictionary that we're passing, you basically use this syntax right here. Whoops. Sorry, hold on one second, guys. Be right back. Sorry about that. Alright, so inside of our template tags, now we can access the data that we're passing through the template. So we named it web data. And then we're going to reference the first object in the list. Is it going to ask us to do it this way? Grade A. So what we're doing is we're accessing web data, the first object within web data, which is going to be, or I guess maybe a better way to look at it. So we're going to access web data, and then the first object in web data, which is going to be the loan amount data that we're passing, and then of that object we're asking it for grade A, which is specified in the class right here. So now if we fire up a test server and run this, we should get the tuple that has the average loan amount and the total number of loans for grade A, if all works as planned. And take a peek and see what's going on. Alright. Alright, so we've got our development server running. We're going to go to our test URL, which is what's going to set off this function. So right now, this delay that we see here is it going through all the hundreds of thousands of rows, and then it should give us an error here. Okay, so we're getting an error. Let's see what we did wrong. For int okay, so what's happening here is it's not liking the value that we assigned to the interest rate data. So I think we can go back and fix that up. So maybe it's thinking it's a Unicode object because it's coming out as a string. So the first thing we'll try is to declare the actual number as a float value, and see if that takes care of the error here. There we go. Alright, so that was the problem. So now, again, on our HTML, we're returning the web data and grade A. So if we really wanted to do something like this, we could, or we could even throw in some tags. So if we wanted to look at kind of all the data from the set, we could do something like this. We run the program again, and it should give us the average and the total amount of loans in each grade. So what we're going to do next time is we're going to take these numbers and we're going to look at some different charts and graphs and some different ways we can visualize the data that we're pulling from the database. But I think for tonight this is probably where we're going to leave off. I realize I left my laptop charger in my office and my battery's about dead. So we're gonna have to cut this one a little short, unfortunately. I'll go ahead and again make sure I add everything that we did today, all of the original data files and everything to the project. So definitely go ahead and download those if you want to. Other than that, before we end off for tonight, I think it's a good place to end off for tonight anyway. And then next week we'll pick up with doing actual visualization. So we'll start the charts and graphs and different things like that. Anybody have anything before we leave tonight? Any questions? No? Alright. Sorry tonight was kind of short, guys. You know, we kind of needed to get through some of this stuff to make sure we're set up to do the fun stuff. So I think at this point a lot of the well, all the groundwork is laid and the tedious stuff out of the way, and next week we'll start doing the fun stuff and making the pretty things, is what everybody I'm sure is here to see. So until next week, thank you guys for tuning in. I really appreciate it. Check out the project description for all the code and everything. If anybody needs anything other than that, feel free to shoot me a direct message, whatever. Alright guys, have a great night. Thanks for stopping by. Alright guys, sorry about that, some technical difficulties, but let's get into it. So, again, everything we've covered up till now has been all Python. We've taken the data from a CSV, we've looked at how we import that CSV data into our local MySQL database. We've looked at how we call the data from the MySQL database, how we take the raw data and transform it into useful metrics that we want to view, and then we've looked at how we take that data, pass it through our program, and eventually out into out into an HTML file that's rendered to whoever's using our application. So today we kind of are going to change pace a little bit. So we're going to be concentrating solely on the front end of our project and visualizing the data that we have pulled previously. And in order to do that, we're going to use some third-party libraries and a lot of JavaScript, the language of the web, if you will, to help us provide these meaningful visualizations to the users of our applications, to help us solve business problems, to present data in meaningful ways. So in order to do it, everything up till now has been pretty straightforward, and now things get a bit tricky in a couple of cases. So this is definitely going to be kind of a multi-part adventure into how we do visualizations. So I've been thinking about the best way to break this out so it's going to make the most sense for you guys. And I think the best way to do it is we're going to cover kind of the fundamentals of NVD3, D3, and then we'll look at how we'll look at some of the challenges that they present when we try and pass our data in a traditional method into those frameworks or those JavaScript functions and libraries that help us visualize the data. And then we'll look at ways that we can work around those difficulties. So in order to start, we got to add a couple of things to our project. So the first thing we're going to need is going to be some stuff that's going to come in handy when we start writing our HTML and start doing our visualizations. So let's see. The first thing we're going to need is a directory to hold all of our static files, our JavaScript files, our CSS files, that kind of thing. So traditionally we'll call that static, and we'll put it in our application directory like so. Within there we're going to need a couple of subfolders. We're going to want one called CSS, and then we're going to want another for JavaScript. We don't want a file, we want a directory. Let's call it JavaScript.js. And then, if we were doing images, we'd put an image folder in here to hold all of our images. So this is kind of where our static files are going to live. So inside of our CSS folder, eventually we're going to want a main CSS file. So we'll just go ahead and create that now. And then I think to kind of simplify things, we'll go back to our views directory, and what we're going to do is we're going to create a new view that we're going to start working on to do the visualizations. So right now we'll call it so essentially right now all we're doing is creating a new view that's going to return a HTML file called -html, which doesn't exist yet. So we will go ahead and do that now. So there's our dash.html file. And then we'll need a URL to help us render that. I guess we don't want a view the same as our program name. So let's go back and change that quick. So we'll just call this dash, just for naming convention's sake. So back to our URLs. Alright. So now we've created a new view, gave it a URL, created an HTML file. Let's just make sure that's working real quick. Alright, so we're good. So we have everything functioning as it should as of now. Alright, so let's look at NVD3. Alright guys, so this is NVD3. So this is a JavaScript library that is based off D3. And essentially what it does is it provides some built-in methods and some built-in functions that are going to help us get some visualizations up and going a lot quicker than if we were going to go with straight D3. So the plan is, what we're going to do today is cover the basics of NVD3. And then next week we're going to cover how we get our data into the functions that we're going to build today. And then after that we'll go back and we'll actually dive into raw D3 and how we can use that to manipulate the graphs we've built using NVD3, as well as how we can use it to manipulate other DOM elements, and just kind of look at the real power that D3 possesses, which is pretty immense. We could spend weeks and weeks going through all the stuff that D3 has. So first we're just going to kind of touch on NVD3, how that's going to get us up and going. And we'll go from there. So to get started, alright, so we're just going to kind of lay out some of the real basic, basic elements. So we should probably declare a doc type. All right. So I'll get started. So one of the first things we'll do is we'll go ahead and link our main CSS file that we just built. So the linking convention is pretty much the same as any other HTML doc until we go to actually reference where we find the template. So everything up till here is, pretty standard, and then we're going to change it up a bit. So the first thing we actually need to do in our file with the Django templating language is provide a kind of a static link or a way for Django to know that we're trying to import our static files, that directory that we just created a bit ago. And to do that, we just simply use the load static command, and that'll give us access to all of these files that we're going to set up here. So then when we get back to here, we can simply reference it with the same template type language. We reference our static folder, then the directory and file that we want, which in this case is going to be main.css. Oops, my bad, guys. So this static folder, when you create your program, you'll have one file, same as your program, that contains your settings, URLs, that type of thing. This needs to go in your application folder, so this one right here. All right. Alright, so that's our CSS sheet. We're going to need some other files that are going to help us along the way here. I will include these with the project file after we're done tonight and upload them into the project folder so you guys can download them directly from here. If you want, you can also go to NVD3, and it gives you instructions on the JS libraries that you're going to need, as well as the CSS that you're going to need. So we want these. We're not going to do. Alright, and then we're going to link these JavaScript files just like we did our style sheet. What's going on here? Oh. And then the last thing we're going to need is a CSS file from NVD3, which is this guy right here. So we're just going to copy this guy. We'll create a new CSS file. paste that into there. All right. So now we have the foundations, and we still got to link this this JavaScript or this CSS file. So we'll do it just like we did this guy. All right. So now we have all the basic references that we're going to need to start building some charts and graphs. So NVD3 uses SVG, which is scalable vector graphics. Essentially, it's standard HTML web format. It's primarily 2D images, but it allows for like some built-in animations and some things like that. And you guys will kind of see what we're talking about as we get into it here a little bit. So the first thing that we're going to need to do is tell our HTML program where we want the chart. And so how we do that is we'll just start a div, and then we'll give it an ID. In this case, we'll just call it chart. So this will be our first. This will be our first graph. It's going to go inside this div, and then we need to also declare the SVG tags. And this will make more sense when we write the JavaScript, but essentially what it's going to do is when we call the JavaScript function, it's going to look for the div ID of whatever we tell it to call. Then it's going to look for the SVG element within that div, and that's where it's going to draw the graph. So if we wanted to put other things in here like a title or a heading, we could do it before the SVG element. So our first one we'll do is a pie chart. So we can call it pie chart, and then we'll draw the graph under it. So we'll go down a ways and we'll start our script. So when we build charts with any of these libraries, D3MV, D3, charts.js, whatever we decide to look at going forward, we're going to need a data set, obviously, and what we want to look at is our data set that we're going to be bringing in. Now that part, as far as looking at the data that we're going to be bringing in, is a bit can be a bit challenging. So what we're going to do is we're going to kind of lay everything out using some test data or dummy data just to get everything working. And then, like I said, next session we're going to come back. Well, this session I'll show you why it's tricky to get our data into it, and then next session we'll come back and look at how we go about actually doing that. So the first thing we're going to want to do is set up a data set. So we're just going to start a normal JavaScript variable. We're going to make an array called data. And then for a pie chart, or this particular type of pie chart, it's going to look for almost like a JSON format. So it's going to look for key value pairs. So it's going to look for, in this case, a label, which if we're using our own data, our first label would be grade A, and then it's going to look for a value. And now in the real world, this value is going to be this right here. But the problem is if we pass this context into our JavaScript here, they don't play well together. It's going to break the JavaScript, and it's not going to work. So this is one of the issues, one of the bigger issues that you'll run across with Django. Is the template language is super convenient. However, there are some cases where it just doesn't play nice with what you're trying to do, and this is a big case like that. And again, next week we'll go into how we get around it. We'll go into how we can render our JavaScript dynamically and some other things we can do to kind of to make it work. But that's the biggest challenge, if you will. So what we'll do now is we'll just input a value of 201 for right now, and then next week we'll actually insert our actual values into the table or into the chart. So we'll just kind of keep getting our chart set up. So then we do a label for grade B. We'll go to value. Alright, and then our last pair will be for grade E. Alright, so this is going to be our test data set. Again, we'll look at how we get our actual data into these values, but for right now, just to take a look at how we get the NVD3 up and going, we'll go with this for the time being. Anybody have any questions at this point? Curious about anything? No? Good. Alright, so now that we have our data, we can start using NVD3 to actually build our chart. So NV has a bunch of, like I said, it has a bunch of functions built into it that lets us build these a lot more rapidly than if we were just using D3. So we use NV, which is one of their constructors, add graph, and then the function that we're going to use to build the graph. So we're going to call it our chart, and now we need to declare what type of chart it is. So just like just like Django has built-in models for database references, NV has built-in models for charts. So we tap into the NV models, and then we can use one of a number of model charts that they have for us. In this case, we're going to do a pie chart, and then we can go in to start using. So so D3 or NVD3, it provides us models, classes, constructors to rapidly build these charts. But the nice thing about it is it doesn't take away the functionality of D3. So you can still use D3 commands and D3 syntax to alter, add to, change, do what you like with the charts. So it's quick, but it's not limiting, which I guess is the big point. So right now we're just going to set up our X and Y axes, and we're going to set it to take the values that we pass to it. So basically what that allows it to do is be self-scaling. So essentially whatever data we pass to it, we want it to look at that data and then decide how to scale the X and Y, so you don't have to worry about manually doing that, which is a nice function. And then we have another constructor function we can call, which is show labels, and then we can set it to either a true or a false value. So we'll set it to true for now, and then we'll go back and look at maybe some other things we can do with it as well. Alright, so that's basically just telling it what type of chart we want and what we want the axes to look like. So then we actually have to kind of call the D3 bit to tell it to actually write us our chart. So we'll use the D3 syntax, which is select, and then we're going to give it the value of the div and then the DOM element within that div we want to use to draw the chart. So in this case we called it chart, so we'll say chart, and then we want to draw with the SVG element. I'll do a space here. Now we're going to specify what data that we want the chart to use, which is going to be our sample data here. So it's going to be our data variable that we created. So we're going to give it a transition duration, which is just going to help it stay where we want it, and we'll call it 350 for the time being. It's pretty standard. And then the last thing we're going to do is we're going to call the chart. And then we're going to return. So that is essentially it. It should give us our I'm just reading over everything here to make sure I didn't miss anything. But this should give us our first pie chart. So we'll run the server here and we'll see what we get. Oh, that's not where I want to go. Alright, so we got our pie chart. However, it is horribly small. So you can see our label within the div, the pie chart, and we'll get into this stuff here in a second. So clearly it looks horrible, even though we did get it. So So let's add some style here to see if we can make this chart look a little more presentable. So we'll go into our CSS file that we created. I'm going to try and make this as light on the CSS as humanly possible, just because this isn't a CSS tutorial. Everybody's going to have their own opinion on what they want to do, what they think is going to look best. So by all means, download the project file, style it to your heart's content. But let's just try giving it a height and a width property and see if that gets us anywhere. So height, let's call it 350 px. I'll give it a width. Let's see if that gets us anywhere. One second here to clear this cache real quick. Alright, let's see if that'll help us out here. So take just a second. Alright. So now we're getting better. Alright, so we cleared the cache, so it allowed us to pull down our new CSS. So we just made it a little bit bigger. So this is our chart that we decided, or that we specified building. So the colors are all kind of the standard colors from MVD3. We can go in, we can change the color scheme, we can change the way the labels look, whether they appear. It's all editable, all customizable, and we'll kind of get into more of that when we start covering the actual D3 properties. By default, our graph is interactive. So if we want to select which grades we want to compare to each other, we can certainly do that by hovering it over. It gives us the actual value or amount of each space. So it's a super quick platform to start getting basic visualizations up and going really quick. So you look at how it's not maybe necessarily the most visually stunning graph that's ever existed to ban, but the fact that we can get that up and running in this much code essentially is pretty amazing. What does line 44 do? Line 44, this line right here. So this is where we start our JavaScript function using the MVD3 library that actually builds that pie chart that we just looked at. So that's just the first line of the function. So add graph is a method within that library, and then it's basically saying we're going to add a chart of some nature, and then we go in, we specify the type of chart we want. We give functions to the X and Y axes to auto scale based on the labels and values that it gets, and then we actually call the chart right here. Alright, sorry guys, we'll be back here in a second. Alright. Alright, Ledger, did that make sense? Alright, Ledger, did that make sense? Alright. If not, shoot me a message. And certainly try and explain it a little bit better. So that gives us our first value. And wow, we're running short on time. Alright, so that gives us our first pie chart. I was hoping to get a couple more charts done today, but let's move on to the next one and see how long that one takes us. So pie chart, very popular type of chart, very popular type of visualization. Next one we'll look at doing via NVD3 is going to be a bar chart. Also one of the more popular types of charts out there, most common. So we'll knock that out. And then if we have time, maybe we'll look at setting up a scatter plot too. I don't know if we're going to get there or not. So we got to give this a distinct ID. We'll call it chart 1. So with MVD3, with D3, any of this stuff, we could continue adding on to this one script tag. And keep going and build our next one, but just in trying to keep things a little more clean and readable, especially if you guys download the project and want to go back and look at the code, we're going to create another script tag and keep them separate. So this one will be our bar chart. So bar chart, very similar. Very similar to the pie chart in the sense that we're going to need data. So we'll create another variable that's going to be a JavaScript array that's going to house our data. So bar charts in MVD3 are super flexible. You can compare, simply one data set. You can compare a variety of data sets on the same chart. So what I'm going to do is I'm going to use a slightly more advanced chart than just a standard bar chart, even though we're just going to look at the standard bar chart today. But what we're going to do is look at probably next week how we can add other things to our same chart to make for more interesting and more meaningful visualizations. So in that vein, where I have key average interest, all we're going to be looking at right now is the average interest. However, when we add other things to the chart, you're going to see where the key makes sense. So then for average interest, we need to provide it values. Now, the values in this chart it's going to by default be looking for an X and a Y value, and it's going to be looking for integers for both. So where this is actually in the end going to be credit grade A, we're going to start out by just calling it 1 for now, and then we'll go ahead and change it to our credit grades when we go through and actually look at how we use D3 to modify parts of the graph. It's going to need a Y value, and just for consistency's sake, we'll use double quotes on everything, even though I generally tend to like single quotes where I can get away with it. So this value here would be our average interest rate for our credit grade A in our actual loan. But again, we're just using simulated data to get these up and running. So let's say 7% is what we're going to guesstimate it as. And then it's kind of the same as we did above. We're just going to go through and specify our x and y values all the way down. And in the scatter chart, we'll get into how we use programmatic loops to populate these data arrays. I don't know if we'll get to that tonight, but it eliminates having to go through and kind of manually code in the values. Alright, so again, this would be credit grade A, this would be credit grade B, this would be credit grade C. This would be our actual average interest rate, which we're going to guesstimate 7, 10, 13. We'll do the last two here. Uh, 20% might be high on the interest rate, but again, we're just guesstimating for now. So that is going to be our data variable. Alright, and then for building the actual chart, it's very much the same syntax as the one we just looked at. So we're going to use the graph. And then we're going to call or declare what type of chart we want. So we're going to call chart, and then we're going to use the NV models. And for this one, we're going to use one called multibar. It's not. It's more complex than maybe just the regular bar chart, but you'll see the advantage of it as we kind of go along. I'm just going to try and go through, set up some of this. Should be fine for now. So we still need to do the accesses. The accesses are done a little bit different in this particular type of chart, but the same thing is we'll use a D3 standard format, and we'll kind of get into more of what this actual syntax is and what it means. There's a number of different things you can do with this, but just trust me that we'll get into exactly what some of these standardized D3 constructors are. So that should be enough to kind of get our basic chart up, and then now we do the same thing we did before. We use the D3 select to pick our div and our DOM element. So in this case, it's going to be chart 1, and then the SVG element. We need our data, which we call data 1. We're going to call our chart, which we defined right here. And then return the chart. Alright. So let's see if that'll draw our little bar chart the way we're hoping it will. It's going to reboot the server. Trying to figure out why our chart's not showing up here. Not sure if it's because of another caching issue, or maybe we need to specify some CSS for it. Sorry about this, guys. We'll troubleshoot what's going on here in just a second. Data 1, that's the correct data set. Let me try. So when you're working with this, when you're constantly redoing, adding little bits of CSS in the JavaScript, sometimes the cache gets in the way and it doesn't register any change on the page, even though you may have given it some new inputs or new CSS. So occasionally you'll need to go in and clear out your cache just to make sure you're able to render a new page. Well, it doesn't seem to be the problem here. Let's see. Let's try. Or maybe I'm just. Or maybe I'm just missing a semicolon. Alright guys, we seem to have hit a bit of a snag, but we'll go ahead and troubleshoot this here in a moment. Just checking out the comments. What's going on? What is HighChart? Do you use HighChart also? I have used HighChart. I don't use it a ton, but I certainly have used it. I probably use charts.js more than high charts, but I probably use NV more than all of them. Just going through here to see what I missed or what doesn't look right. Sorry, bear with me, guys. I'm just gonna add a few parameters in here to see. My editor's being goofy too. I feel like maybe it's just my editor being goofy on me. Well, it looks right. Alright, guys, bear with me here for a minute. Hopefully we can try and figure this out before we gotta go tonight. Anything jumping out at anybody? Good old coding. If it worked as we anticipated all the time, it wouldn't be any fun, would it? Let's see. Have you checked the data source is connected? So for this particular example, we're using a representative data source, which is this variable here. So this is our data set that should be rendering in the bar chart. And then we'll go through eventually how we convert these example bits of data into our actual data that we've already queried from the database. But it's a little trickier than it appears on its own. So we will certainly cover that. I feel like I've just got to be missing a comma or quotation mark somewhere. Let's try one. I do have SVG. It's bizarre. Alright, I'm going to give us about another minute, and then we can't figure out where our issue is. I will figure that out offline, and then update the project with the correct code here. But this should work. I can't see where my error is, but I'm sure there's one that exists in here somewhere. These are all fine. No comma. Data. This will make any difference. I feel like maybe it's not reading our CSS right. Let's try something dramatic. Or, yeah, let's try this. Let's see what happens if we put our CSS directly into the template. My editor is just wigging out today. I think maybe it's just an issue. I need to restart my computer or something. Things are kind of going nuts here. Anyway, let's see if that made any sort of a change. Alright guys, I think my computer might be going wonky and my dev server isn't working quite right. No, I haven't found the mistake. I don't think there is a mistake. I think maybe my dev server and my computer is just being wonky at the moment. So I'm going to go ahead, shut down. We're going to call it a stream for the night. I'll reboot, and then if the error is still there after that, I will find it and update the code, and then update update the project page with the correct code. And then when we come back next week, we'll cover what the problem was. But I'm thinking my computer's just being goofy at the moment, because there doesn't appear to be anything that's off in here. I think maybe my web browsers are just being wonky. My dev server's not working the way it should. So that's the plan. Thanks everybody for turning in tonight. I apologize. I was hoping we'd get a little further than we did today, but we had some audio problems at the beginning, and then a little bug that needs to be worked out here. I'm gonna try one thing actually. I'm gonna try and spin up a different instance or server here. Give me 1 second. Maybe we'll see if we can crack this a different way. That's more or less what our bar chart's supposed to look like, but something's still going haywire on me. I'll go ahead. I'll fix this off camera, and then when we come back next week, I'll show you guys what was going on. Again, I think it's just my computer going wonky. But we'll take a look at that next week. We'll take a look at some other graphs. We'll look at how we. All right, guys. I apologize for last week. My day job has been rather hectic the last couple weeks, so I haven't had as much time as I'd like to devote to kind of preparing material for you guys. So that's my bad. Hopefully, if all goes as well this next week, most of that stuff will wrap itself up and be able to devote a lot more time to this again. So in the next couple of weeks, if there's anything in particular you guys want to see, feel free just to shoot me a private message or whatever. Let me know what's up, and we'll be sure to cover it. Today, with the holiday and the work stuff, it's probably going to be a shorter than usual session. We're going to hit Charts.js, take a look at some of the pros and cons of Charts.js versus NVD3. For anybody that was watching last week, we had a bit of an issue with the code at the end. It actually wasn't an issue with the code. It was an issue with my my browser cache was kind of not working the way it was supposed to and refreshing properly. So let me show you kind of where we ended up there. So last week we were having a bit of an issue getting this graph here to work. If you're following along, all the code was correct. However, for whatever reason, the browser cache wasn't pulling the new code after we made the CSS changes. So if you go in now, you will be able to, that same code, and I also upload the project file with the code to generate this graph using NVD3, and I also threw in a spare graph and then the code for a more or less random data generator. If you've parsed around NVD3 at all, you're probably familiar with that. Just to let you guys know, all the project files current to last week. Oh, this is going to create an echo, my bad. Sorry. All the project files current to last week are now uploaded into the folder. So if you guys want to download all the code to where we're at as of the end of last week, plus the additional code for this stuff, go right ahead. It's on the project page. You can find it there. We'll make sure we upload the code we do today as well, so you have all that. And then just one moment here, and we'll go ahead and get started. Alright, so today we're going to take a look at Charts.js. We'll look at some of the pros and cons versus NVD3, which we looked at last week. Today we're actually going to make the first meaningful chart with the data that we've extracted over the course of the last few weeks. which is kind of cool. And then we'll kind of go over some of the pros and cons of NVD3 versus Charts.js. And it may be a quicker than the normal session tonight, but you may get some bonus footage. I have another project that I need to get started on as well, so we'll run through building some Chart.js stuff quick, and then see what it looks like, and then after that we'll see where we end up. But I may end up flipping over to a different project I need to start and get going for something else. All right, so Charts.js, here it is. First thing we need to do is download the Charts.js JavaScript file. So right through their site, we'll just go with the whole bundle here. I think you could probably do the min and be just fine. But we'll do the whole thing just to be safe. First thing we're going to do is just copy the whole file. And then we need to add this into our project here. If you guys remember from before, all of our JavaScript files are kept in our static directory. So all of our CSS will be here, JavaScript here. So we're just going to create a new file. We're going to call it whatever you want, but well, I guess we call it chartjs.js, even though it's kind of a weird convention. It makes sense in my head, so hopefully it does in yours. But if you want to call it whatever you want, feel free. So we'll go ahead and create the file. We'll paste in all the information that we just copied from here. And we now have Charts.js installed in our project. It's as easy as that. We're not really going to do anything with the JS file, so we can close that out. Maybe. Possibly. OBS Studio's killing my RAM. Anyway, it's there. We're not going to do anything with it. As long as we've added to the project, you essentially have it installed into your project. Alrighty. So where do we want to go next? So let's create a new URL. So our old dashboard URL was our NVD3 graphs. We're going to start with a clean sheet for this one, just to kind of keep things separate. So we'll call it dashboard 1 or dashboard Chart.js. Yeah, dashboard 1 seems easier. Let's go with dashboard 1. Views dash Chart.js. So it's not going to recognize this view because we haven't made it yet, but we're going to go ahead and build that next. So let's go into our views. So maybe next week we'll go over, well, I think next week we'll cover straight D3 for a little bit, and then maybe we'll get into how we pass data into NVD3 and D3, or we might break that up into 2 sessions. I'm not entirely sure just yet, but anyway, eventually we'll get some data in there. So for today, we're going to start a new view. I hope that's what we called it. I think it is. I'm going to expect a request. Was that what we called it? It is. Beautiful. Alright. So we're going to get some data. Eventually, we're going to return. If you guys hear some weird background noises, it's my dogs. Yeah, I apologize for them. They go crazy and do what they do sometimes. So we have a new view that is eventually going to render a new HTML template, which we haven't set up yet, but we'll go ahead and do that next. Gus, hey, yeah. We'll go ahead and set up this template here in just a second. And essentially what we're going to want to do is, if you guys remember in our test document we did in, give me 1 second here. Our little test HTML document we did, it might have been week 2 or 3. We can look at it quick. So this is our test HTML doc, which we did again week 2 or 3. Basically, we just looked at how we pass data right here, how we pass data into the HTML web page. So we want to do this same thing to get the same result, to get the second column of data here is what we're particularly interested in for this. So this is what we did week 3. So we're going to kind of duplicate some of this a little bit. So we want to get the same data, and then we also want to pass it to the web page the same way. So we're just going to go ahead and add that down here. Oops. Should probably add this. Alright. So a super quick recap of what we're doing here is we're just querying the SQL database that we built. We're pulling all of the loan objects, and then we're returning the data that we parsed out here in this file with this function right here. So we're querying the data that we need. We're giving it. Here we're querying all the data. Here we're running it through the function that we built, getting the data that we want. And then here we're passing it through to the HTML page. So now we need to actually build the HTML page. So we just go into our templates. We add a new HTML file. Call it dashboard charts.js.html. We'll give it a title, charts.js. Just it can be whatever you want. And then we're going to go ahead and start building our new charts.js graph here. Alright, so the first things that we'll need to do is make a couple of links. So we're going to want to be able to pull our charts.js script into the file here, and we're also probably going to want our CSS in here as well. So we're just going to create a couple of links before we get too much further. First one, we'll pull in the script database. So it's not recognizing the file here, and that's okay. All we need to do is make sure we provide a reference to our static libraries. So we'll just load all the static libraries here, and that should resolve it. Actually, we call it charts.js.js. All right. Still giving us an unresolved template reference. It's because there's no S in there. All right. So now it sees our charts.js file that we copy and pasted just a bit earlier. And then the next thing we'll do is we're just going to link our CSS document. Sorry guys, I'm woefully unprepared for this, but we'll kind of freehand it. We'll get it figured out. We'll make it work, and hopefully we'll have a beautiful graph with our data. At the end of it. That's about right. All right. So now we've linked in our charts.js file, then we've linked in our CSS file here, which will, we may or may not need to use that here tonight. All right, so back to our HTML. So one of the main differences between charts.js and NVD3 or D3 is D3, NVD3, they use SVG. Charts.js uses a lot more traditional DOM model, which makes it a little bit to a lot easier to work with depending on exactly what it is you're trying to do. Let's just do a real quick test and make sure we've got this set up okay. That would be the problem. Alright, let's test this quick, see if our page is rendering. Before we do that, we should probably remember what we gave the URL, dashboard1. It's going to take a minute because in the view we told it to go ahead, pull all of the data from the database, run it through our function. So it's going to take a second because it's actually going to do that and then pass that data to the HTML, even though we're not going to see anything behind the scenes. It certainly is happening. Alright. So we mislabeled something. Dashboard charts.js. Alright. So I missed an S here. And for the time being, just to make this a little quicker, I'm going to comment this out. So we're just going to make sure this will load quick, and then we'll go back to that. Yeah. Of course. And because it's expecting the return data, we really can't comment it out. As we could have just deleted the return data, that probably would have been quicker. But hopefully this will work, and we can move on to actually building our graph. Alright, so we do have a functioning web page now. We have the data that we're looking for being transferred to the web page. So things are looking up. Alright, so as I was mentioning before, NVD3 or D3, I guess I should just say D3 because NVD3 just uses D3 in a simplified version. So D3 uses SVG. Charts.js uses a much more simplified traditional DOM type scheme. So instead of needing an SVG element, we're basically going to give Charts.js something called a canvas. We're going to reference the canvas in our JavaScript function, and then that's going to tell it where to draw our chart. So the first thing we're going to need is a div to hold it. We'll call it Chart.js1. And then the element that we're going to use is a canvas. So it's this guy right here. We need to give the canvas an ID because we're going to reference that in our model. We can just call it chart1. And then we have a couple of options. We can either specify height and width within the canvas ID, declaration here, or we can do it in our CSS later. We'll try it both ways and kind of see what kind of result we get. Sorry about that. So let's just give it a width and a height. Call it 400 px both ways. Alright, so this is our canvas element. All this is doing is eventually going to tell Chart.js where we want to draw our graph. And as we go along, maybe we'll build some more complex dashboards. Or if you guys want to see, I can show you an example of dashboards I've built with both, and you can kind of see a little bit of the difference. Yeah, maybe we'll do that. That'd be a good thing. You can kind of see all this in real production, usage type fashion. So you can kind of see where the end game is, if you will. So we have the div. We're giving it the canvas, so it knows where to draw, and then we're gonna start our JavaScript. So again, using the more traditional model, we're going to create a var called CTX, and I'm not off the top of my head certain why we call this var CTX. It just happens to be the convention that Chart.js uses. Maybe by next time I'll know. But for now, we're just going to use it as our main. We're going to use it to associate to the canvas is what we're going to do. So we're just going to do a regular document, get element by ID. And then the ID is going to be what we just named it, which is going to be chart1. And then this is an optional parameter you can use as get context. and you can pass it a number of different values, but for our graph here, we're just going to basically specify that we're building a 2D graph. Maybe we'll get into some of the more advanced stuff as we go. So then we're just going to name our chart here, which creatively we'll call it my chart. And then this is kind of where the charts.js back in JavaScript is going to kind of come into play. So we're going to go with the CTX. And then we need to start specifying some things. They make it, charts.js makes it fairly easy on you. The syntax through almost all of the charts is going to be almost identical. The options are going to vary based on the type of chart, but the structure is going to be very much the same. So for type, it's as easy as just telling it we want a bar chart. It's literally that simple. So now that it knows what type we want, we need to specify what data we're going to feed it. And this gets, I don't want to say complex, but we have some things we can specify inside of our data field. So the first thing we're going to want is labels for our chart. Being that we're comparing the credit grades again, we're going to call, we're just going to do the grades across the board. So we'll do grade A. And I think it was just A, B, C, D, and E, if I remember correctly. But we can fix that as we go. I think it was just the 5. If not, we'll certainly add more. So we have the labels here. Now we need to specify some of the actual data that's going to go into the graphs. So our first line here, these labels are going to be the bottom axis labels, the x-axis. So we'll see grade A, B, C, D, E. Here we can actually give the entire graph a label if we want to. So we'll go ahead and do that. We'll just say credit grade versus loan volume is what we're going to actually look at. So in this graph we're going to kind of compare who borrows the most money by credit grade, which could be interesting to see, at least to me. So now we need the actual data. So this is the data that we are pulling in from our view function. So this we need to translate in here, and we're going to do it in a similar fashion that we did in our test. So where this syntax gave us the tuple of the total number of loan amounts and then the total loan volume, we're going to access it in much the same way. So we're going to say this is the data that we want. So this is that tuple. but we actually want the second value in the tuple, the loan volume, not the total number of loans for this particular graph. So we're going to reference the second value in the tuple by just adding the dot 1. So this gets us the tuple. This gets us the second value in the tuple. If we wanted the total number of loans, we'd reference the first value, which would be dot 0. So 1 gives us the second value. So we're going to do this for each of our grades. So we have grade A, grade B, grade C. Yeah, we're getting long. Whatever. We'll break the rules tonight. We're feeling like rebels. D and E. All right. We were rebel for a minute. Now let's go and fix this a little bit. That'll work. All right. So we have our labels. We have our data for the x-axis. So this is going to pull in the total volume of loans for each of the credit grades. The y-axis will basically do itself. This is the beauty of using these third-party charting libraries is we don't have to know the range that these values are going to come into play. It'll figure it out for us. It'll scale the graphs. In theory, it should be, it should be lovely. All right, so now we can do a couple of different things to more or less define the look of the graphs. So the first one is we can define the background color. If I could spell, we could. Define the background color of the bars themselves. Should be capital C here. Now, we can do this in a couple of different ways. The easiest is probably RGB values, which I have pre-produced for us here. So I'm going to go ahead and just paste those in to save us from having to type this stuff out. We're just going to assign some colors to the actual bars. And then the other thing we're going to do is define a border color. And then I have these pre-prepared for us as well. There's a little darker version of the actual background colors. And then border width is just takes a numeric value. One's going to be the thinnest. If you wanted to make them really thick, you could enter into 10. But this should get us what we need as far as just a fairly thin border. So that kind of takes care of what we need in the data sets. There are a number of additional options that we can add. We probably won't get too in depth with the options today. I'd suggest reading the documentation. It'll give you a little better idea of what's going on with the options, some of the things that you can do with them. My dog's going crazy. So one thing we will specify is the ticks, and we'll just make sure they start at 0. We'll do that by using the begin at 0. And we'll just set that to true, maybe. And then there's a lot of different options you can add to your graphs. Whether you want tick marks, whether you don't want tick marks, whether you want numbers every tick mark, whether you only want them, periodically. There's I won't say an infinite number of adjustments that can be made, but there's a pretty substantial number that can be done. I'm just reading through this, make sure it looks like we have everything we need to generate a graph. It looks pretty good. I should probably end the function. But other than that, I like it. Let's give her a shot and see what happens. I feel like we're missing something, but we'll find out. So let's see if we changed it's working to a real live graph with data that we mined from our database. And beautiful. We have something. Looks great. Kind of surprising. Just off the top of my head, I don't know that I would have expected the middle credit grade to have the highest loan volume. When compared to some of the better credit grades, and I'm assuming this is just, what are we getting here, 5196. I'm assuming this is just because of difficulty getting loans, and maybe that's, credit grade A doesn't borrow much because they're better off financially. I don't know. But it's interesting data to take a look at. So Charts.js puts these tags in based on the labels that we specified. So, if we want to get an exact number for what we're putting in, we're looking at 34,610 is what the total loan volume was for credit C, 29,521 for credit grade B, 15,359 for credit grade A. So we have ourselves a real life graph with real data that we mined originally from a spreadsheet, then converted into our database, and then wrote a function to sort through hundreds of thousands of rows and dozens of columns and get us an end result here. What I will show you guys is a couple of different. Let me show you guys a couple of things. So let's get rid of this, get rid of this, get rid of this. This is, I'll show you guys a couple of things, and then we're going to kind of call it an evening here. I just want to give you, this is NVD3 again. This is our Charts.js graph we just built. I'm going to pull this off screen for a second so I can pull up some sites and type in some credentials. This is VisiFly.com. This is a site I built a while back. It's basically a data analytics platform for direct-to-consumer type marketing businesses. It taps into a very particular CRM and produces charts and graphs and things like that. So this is a semi-generic dashboard template, but all the graphs are generated via NVD3. So this is a real-life example using what we learned up through last week on what can be done with just that. So this is all NVD3. Again, everything's interactive, which is one of the cool parts about NVD3. So anything you can go in if you want to remove data, add data, look at specific comparisons, change the way the data is viewed, all that kind of stuff. It's all pretty easy with the NVD3 stuff. And then let me give you an example of a Charts.js dashboard that I built, just so you can kind of see some of the difference. Now this one is technically still, this is actually a product. I don't have a demo of this one, so we're gonna have to look at a production one. So let me see what I can do to obscure any names that need to be obscured. It's taking me just a minute to log into this guy. What would be a good one to look at? Alright, so, there we go. Alright, well, it mainly obscures anything that needs to be obscured. So this is an example of a Charts.js dashboard. So what this is it's just call center data. It's taking a look at how the client's campaign is performing within the call center. So this is all real-time data, up through right now, and then graphed out using Charts.js. So you can see kind of the difference between, I closed that already, between the NVD3 and the Charts.js. They certainly have different capabilities. Charts.js is definitely a lot easier to work with in a lot of ways and a lot quicker to get things up and running. It can be a little easier when it comes to replicating. Whereas NVD3S or D3 is definitely a lot more full-featured. It offers you a lot more functionality. There's a lot more things you can do with it, but with those benefits comes a cost that it's a lot more complex to work with. And we'll kind of go into we saw a little bit last week or the last session on why that is, and then next session we'll probably go into a little deeper on how we combat it and more why it's complex with Python and Django particularly. Whereas we see in this example, we're really easily able to pipe in our data right into the graph in the form that it's expecting. If we tried to do that with our NVD3 that we did last week, if we tried piping that data in right here, it breaks the JavaScript. So what we have to do is essentially dynamically render all of our JavaScript and then pass our data in, which adds a bit of complexity to the program. It's not as simple as just dropping it into the HTML like we just did with the Charts.js. And again, we'll look at that more next session. But just to give you guys an example, endgame, what's possible using the things that we've covered so far. The first demo I showed you, that visifly.com, that's all 100% NVD3 graphs. The second one, all 100% Charts.js graphs. So, using what we've learned with adding in a little additional HTML handiwork, you really can produce production level dashboards, production level data visualizations that really can not only wow people, but help them make meaningful business decisions at a much faster pace than they would ever be able to do trying to sort through this data off Excel spreadsheets. Any other questions? Sorry, I neglected the questions. Thorvald, what are you doing with the CSS here? In this example, we didn't really even have to do anything with the CSS because we specified it in our canvas declaration right here. So we could have just as easily not specified this here. And we could have just called it chart 1 and then it went into our CSS. And this is probably more of the proper way to do it. So we could just call it charts.js1, which I think is what we called it. Chart.js1. Chart.js1, yeah. So we just go in here and then we could specify it here. So that would work just the same. When you actually start making a production application, you're gonna want to probably go about it that way, and you get the same result. But that's where the CSS comes into play. Maria NYC, I love this project. I'm glad you like it. I will, if not tonight, early tomorrow, get the new project files uploaded into the project so you guys can download those, play with them, do what you will with them. Other than that, unless anybody has any questions or anything they want to see for tonight, I think this is where we're going to go ahead and call it a day. I appreciate everybody checking out the stream, following along, taking part. It's been a lot of fun. Next week the plan I think will be to get into either get into remotely or dynamically generated JavaScript, so we can go back to getting our data in through the NVD3 graphs, or we can go ahead and look at D3 on a more, I don't want to call it cellular level, but on a much more lower level, we can look at D3 and some of the features it has and the powers that it has and how we can use that to manipulate some of the NVD3 stuff and just create graphs from D3. So if anybody has any preference either way, shoot me a message, let me know. Otherwise, we will wing it as we go. Other than that, thank you again, everybody, for checking out the stream tonight. Sorry it was kind of short with the holiday week and busy work schedule. It is what it is. Tune in next week, and hopefully we'll have a little more fun. Thanks, guys. Have a good night.